오케이, 됐다. 됐어요. Okay, I'm ready.
Ready?
Yeah.
Yeah, I think you can go.
Okay, we can go. Great. Good morning. Good morning. Okay, welcome to the second day of the KEAMSAC conference 2022. Our first presenter is going to be Nolan Hildebrand from the University of Toronto, who is joining us via Skype. His paper on computer-aided composition, timbral synthesis, and electro-acoustic super instruments, and exploration of heaviness in electro-acoustic chamber music is what he's going to present. So welcome, and it's all yours.
Yes, sorry, I muted.
Okay.
Okay, we can hear it now.
Got it.
Yeah, sorry. And everyone can see my screen here?
Mm-hmm.
Okay, perfect. Just give me 1 second, sorry. This just shut down on me. Okay, thank you. Hello everyone, thanks so much for being here. Very excited to be here. Greetings from Toronto. My name is Nolan Hildebrand. As mentioned, my presentation is entitled Computer-Aided Composition, Timbral Synthesis, and Electro-Acoustic Super Instruments, an exploration of heaviness in electro-acoustic chamber music. So first I'm going to start off by giving an introduction, and then I'll discuss super instruments, discuss different concepts of heaviness, onto my compositional working methods, an overview of the electronics, and then an overview of how I utilize computer-aided composition, source bonding and timbral synthesis, spatialization, and then finally on to conclusions. So, introduction. In his article, Reigen Seliger Geister, on my second string quartet, Helmut Lockenman uses the term super instrument to describe moments in his work where the string quartet is treated homophonically as a single 16-string mechanism through the unison sound and unison wrestling, i.e. the synchronous multiplication or amplification of sound or noise, and or the parallel deployment of tones greatly separated in sonic space. In my master's thesis composition, Tripping in the Hor Vacui for amplified violin, amplified cello, and amplified piano with electronics, Lockenman's idea of the super instrument is extended with digital music technology and electroacoustic tools such as computer-aided composition, timbral synthesis, live processing, and multi-channel spatialization. By utilizing computer-aided composition, I derive pitch information from noisy samples of raw data sonification used in the work's mixed media/beat.
quite a while ago.
Oh, I'm sorry. Okay, I'll try to share my screen again.
Okay.
Yeah. And I'm not sure how to see notifications. Maybe just mention it in the, yeah, you did mention it in the chat. Okay, I'll try to keep that open.
Yeah.
Sorry about that. I will try to share my screen again. Okay, can you see that?
Mm-hmm.
Yes.
So did I get through this or did it cut off before this?
You got about 2/3, 3/4 the way through.
Okay. It's really sorry about that. Okay, well, I'll just start from here. In my master's thesis composition, Tripping in the Horror Vacui, for amplified violin, amplified cello, and amplified piano and electronics, Lockenman's idea of the super instrument is extended with digital music technology and electroacoustic tools such as computer-aided composition, timbral synthesis, live processing, and multi-channel spatialization. By utilizing computer-aided composition, I derived pitch information from noisy samples of raw data sonifications used in the work's fixed media / tape track. This pitch material derived from the raw data sonifications in the fixed media is then mapped to the performer's instrumental writing to create homophonic textures. The material between the performers and the fixed media is then synthesized in the performance space with either a stereo or 7.1 multi-channel speaker setup to create a huge and distorted electroacoustic super instrument. Creating these electroacoustic super instruments in my own works allows me to sculpt enormous melodic gestures that stretch out over the multi-channel speaker setup, thus also incorporating the parallel deployment of tones greatly separated in sonic space. In Tripping in the Horror Vacui, these larger-than-life electroacoustic super instruments embody a maximalist aesthetic to create a heavy and sublime experience that overwhelms the audience through metal music tropes, density, intensity, and amplitude. Can you all still hear me?
Yes.
Okay, great. So on the super instruments, I posit that there are 3 different categories of super instruments. In the acoustic realm, we have it usually manifesting itself as an orchestration technique. And in the electroacoustic realm, it's augmented and supplemented with electronics. And these 2 categories can be combined to create a 3rd hybrid category. So in the acoustic realm, Lockenman uses the term super instrument to describe the orchestral technique of combining multiple acoustic instrumental voices into a single sonic entity. This orchestral technique has been explored by composers throughout music history. Prominent examples in the 20th and 21st century include Louis Andriesen's Workers' Union, where, quote, everybody, the performers and ensemble, plays in unison throughout, one voice united in delivering the same emphatic message, unified in their intent, end quote. Greenberg describes a similar effect in Haya Cherubin's work, Sahav, which features a climax where the ensemble becomes an enlarged ratchet via this same orchestration technique. The possibilities for creating electroacoustic super instruments are endless, as can be seen by instruments showcased at conferences like New Interfaces for Music Expression, NIME, and National Association for Music Merchants, NAM. There is classic electroacoustic live processing, as can be seen by Todd Mackover, for example, who creates what he refers to as hyper instruments through the augmentation of acoustic instruments with digital extensions to give extra power and finesse to virtuosic performers. Other examples can be seen in more commercialized instruments like the recorder and the Akai electronic wind instrument, or EWI, as shown here. And everyone can still hear me?
Yes.
Okay, great. Just worried about dropping out again. Although Kalanopa and Gastelceder initially state that live electronic processing distinguishes a true super instrument from other situations where a fixed media background is being used, they settle on a less precise definition, which is, quote, a super instrument or super instrument composition should be defined as an entity in which all the instrumental lines or computer-generated features complete each other in a manner which does not allow them to form separate identities, but to form an organic unity with its own congruent identity." End quote. So Tripping in the Horvacui explores the concepts and aesthetics of heaviness. Heaviness in music means many things to different people. It can be used to refer to the literal material of the music, as well as the metaphorical, expressive elements of the music. I seek to explore the material references of heavy timbres and the idea that heaviness is the music's perceived size, weight, and density. Metal music theorist Calder Hannon connects rhythmic complexity to heaviness, as well as the idea that, quote, "compositional choices, not just timbral or textural ones, and beyond surface level melodic and harmonic ones, can contribute to heaviness by enacting metaphors for both the material and expressive dimensions of heaviness." In this work, heaviness is manifested musically through noisy electroacoustic super instruments, sound masses, crushing drones, and rhythmically complex metal-inspired riffs. The idea of heaviness as music's perceived size, weight, and density lends itself well to theories on excess, maximalism, and Kant's aesthetic philosophy on the sublime. When discussing maximalist noise and drone music, Joanna Demers states that, quote, "sublime objects are impossible to encase within a frame because of their sheer scale. They inspire within the viewer a sober respect of awe that Kant describes as a negative pleasure, whereas beautiful objects elicit unambiguous pleasure thanks to their adherence to perfect, universal, recognizable forms." End quote. The work therefore also achieves this metaphorical heaviness through the creation of huge and sublime musical objects. So when beginning Tripping in the Horvacui, I took a sound-up compositional approach that began by layering sounds and improvising in the studio. This writing process brought forth the form, gestures, spectromorphological changes, and heavy timbres that were injected into the written parts for the performers and their instruments. Because much of the groundwork for the piece was created through improvisation in the studio, and because I would add to the music sequentially, the generated form was through composed and intuitive. So the starting point for the instrumental writing began with superimposing a harmonic scheme to ground the fixed media. The fixed media does not adhere to any harmonic scheme and is more freely composed in terms of melodic and harmonic material. I chose to start this scheme on a C cluster, as we can see here, because one of the first electronic gestures I created consisted of a low C drone, and I wanted to pair the sound with the bowing of the string wrapping on the C string of the cello. As we can see, new pitches are gradually introduced throughout the composition until the end, when all pitches are available to performers. The black line around the MIDI roll is a tracing of the performer's written pitches, which illustrates the tessitura of the harmonic scheme and how harmonic width is being utilized throughout the work. The electronic components of the piece consist of fixed media that performers synchronize with via a click track routed to individual headphones and live processing with distortion, delay, and reverb using stock plugins in the digital audio workstation Reaper. Using stock plugins will ideally create a work with accessible electronics. This processing is automated so that it starts, stops, and involves in conjunction with the fixed media without the need for triggering by the performer. The fixed media and the click track is also handled in the same Reaper session as the live automated processing. The textures fixed media combined with the amplified and processed instruments and the spatialized gestures create a convincing electroacoustic ensemble that is powerful and musically expressive. For the final section of the work, I used various samples of noisy raw data sonifications that are arranged to create a noise collage. Raw data sonification is the use of representation of data through sound involving a mapping process into the aural realm. To create the instrumentalist written music for the noise collage section, I used simple computer-aided composition in Reaper. With Reaper's record MIDI output mode, I was able to extract pitch information from the raw data sonifications and record it in the form of MIDI information. The pitch material extracted from the raw data sonifications in the fixed media is then doubled in the performer's instrumental writing to create massive electroacoustic super instruments. When extracting the MIDI information, the pitch material in the raw data sonification can move very quickly, is extremely complex, and often unplayable by humans. To create a convincing electroacoustic super instrument, I manually quantized some of the melodic gestures from the raw data samples to a click track grid to make the instrumental writing more rhythmically feasible for the performers. Samples that were not fixed to the grid created a more compositionally free scenario where I would pick and choose the notes and rhythmic structures that were most important and could most easily be transferred to the instrumental writing. This allows space to create melodic material that, while taken from the raw data sonification, is not a direct transposition. So this slide shows MIDI information that was extracted from 3 different raw data sonifications, each lasting roughly 1 measure, measures 193 to 194. I'm not sure if you can see all these circles here, but there's some blue circles that denote pitches that are a direct transposition from the raw data sonifications, while the red circles denote pitches that are harmonized, usually in seconds, while both circles denote a harmonized and direct transposition between the different instruments. The rectangle around this MIDI gesture, around this gesture here, is an example of a raw data sonification that has a very clear and more simple melodic motif that could easily be mapped onto the instrumental writing. So I'm going to quickly play this section. It's rather quick, so I'll probably play it twice. Hopefully it all plays fine. Let me know if you don't hear anything. And if you don't say anything, I assume it's fine. All right, here we go. Everyone hear that?
Yep.
Okay, I'll play it again. It's very quick. So beginning now. So that last gesture there, that was this part here. So moving on to measures 219 to 224, this is an example of a raw data sonification where the only real distinguishable MIDI information comes at the end of the gesture, these F5s here that are circled in blue. Because the pitch information is moving too fast and sporadically, the computer-assisted composition tools used to extract MIDI information gathers very little, despite the raw data sonifications being full of pitched material. In this situation, I took a bit more of a traditional transcription approach, where I listened to the sample and analyzed the audio file waveforms to compose a gesture that matched the raw data sonification sample in a convincing way. So now I will play this section quick. It's kind of quiet. Just give me a second. All right, here we go. Sorry. This is where it is. So play that one more time because it's very quick. Great. So although there are far more advanced computer-assisted composition tools available, like Open Music and Orchidia, that can automatically orchestrate sound files, because the pitch material in the raw data sonification samples is so fast and complex, these programs would have still likely produced unplayable results. Therefore, the simple and flexible workflow of the record MIDI out function was preferable because of the orchestral freedom it allowed me. Using MIDI information derived from raw data sonification melodic gestures illustrates a new and exciting way to create electroacoustic superinstruments. Taking this sound-up approach to composing for electroacoustic ensemble where the synthesis of electronic and acoustic sounds becomes one giant composite gestalt is an almost constant presence throughout the work and contributes greatly to the perceived heavy aesthetic. So moving on, tripping in the Horvath UI, Intricate in the Horvacui, the violin, cello, and piano are all amplified and processed with distortion, delay, and reverb throughout the piece to bring the instrument's timbres to the same plane as the fixed media. In the 7.1 speaker setup, I use the three front speakers, the left, right, and center, on stage and in front of the performers as localized sources for their amplification and processing, as this creates a more convincing electroacoustic super instrument. The fixed media is therefore the main vehicle for the spatialized gestures in the multi-channel setup. When played through loudspeakers in the performance space, the live processing of the acoustic instruments and the fixed media fuse together via source bonding, where listeners group the fixed and live sounds because they are emitting from the same source. This source bonding is of course amplified through the use of homophonic textures between the electronic and acoustic voices. For example, the second section of the work is based on the metal style known as gent, which is characterized by rhythmic complexity and distorted low-tuned guitars. This section was created using similar rhythmic complexity and samples of distorted electric guitar, which operates as the most recognizable signifier of heaviness in gent and metal music. During this section, the instruments are distorted and compressed, synthesizing their timbres with the guitar samples in the fixed media. Both the live and fixed elements play a C microtonal cluster to create a massive electroacoustic super instrument playing heavy unison gestures that showcases rhythmically difficult playing, as can be seen in the score here. As Calder-Hammond states, rhythmic difficulty enhances heaviness through various enactments of sonic metaphors for size, weight, power, and density. So now I will quickly play this section. Everyone can still hear me here?
Yes.
Okay, great. Here's this section. So again, pretty quick. So I'll just play that one more time. I didn't mention, but obviously we're listening to the stereo version right now, so we're not necessarily getting the spatialization that I'm talking about, but I think it still gives a good idea. So the piece is written for either a stereo speaker setup or a 7.1 speaker setup. The intention of this speaker setup is ideally to subsume and overwhelm the audience with sound. Because much of Tripping in the Horvacui is an exploration in heaviness and density through difficult unison rhythms, I had to find ways to create interesting spatialized gestures without losing the clarity and precision of the music. In the opening section, Noise Drone Mass, the spatialization can be heard in the tension and release with a sweeping raw data sonification and inharmonicity with high sine tones with slow wide vibrato. In this opening section, there are three large noise drone gestures. In the first gesture, the raw data sonification sample moves from the center, right, and right front speakers diagonally and back to the left front and left mid speaker, as we can see on the left side here. The spatialized movement makes it feel as though something is flying over the listener from front to back, receding and fading away. As the raw data sonification gesture ends, it dovetails with high sine tones, which crescendo from the right mid and left mid speakers straight across the speaker array to the center, left, and right speakers. The second drone noise mask gesture uses the same spatialization but begins and ends on opposite sides, beginning in the center, left, and left front speakers before moving diagonally and back to the right front and right mid speakers. In the third drone noise mask gesture of the opening section, the raw data sonification sample disappears and the listeners are left with transient clicks and snaps that swirl and bounce around the listener in an irregular, unlocalized motion inspired by Trevor Wishart's diagram from On Sonic Art. So I will quickly play this example. So the jet section is an example of a section that requires precise rhythmic unison and homophonic textures to create an electroacoustic super instrument. Moreover, spatialization can be heard in the 8-bit sound effects in the fixed media, which jump randomly from speaker to speaker. At the climax and subsequent ending of the jet section, arpeggiated 8-bit samples, processed oboe and recorder play quick 16th note rhythms, which are being imitated by the pianist's right hand. These are spatialized in rapid circular back and forth motion to create an overwhelming flurry of jittery high frequency pitches. This was inspired by Trevor Wishart's diagram over here, the unlocalized zigzag pattern. So I don't think I have time to play that example because of some tech issues, so I'll jump to the end here. So in conclusion, electroacoustic super instruments can be achieved in a variety of ways. In this presentation, I have illustrated how I use the more traditional acoustic orchestral technique of creating a super instrument combined with electroacoustic tools and digital media to create a heavy and sublime electroacoustic super instrument in my work, Tripping in the Horror Vacui. Electroacoustic super instruments offer the potential for further research and research creation projects focused on electroacoustic timbral synthesis. Further directions include a commission from the University of Toronto's Tapir Lab to compose a new work for percussion sextet and electronics. This work will be a more concise exploration of an electroacoustic super instrument that exclusively uses the computer-aided composition technique of extracting melodic and rhythmic gestures from samples of raw data sonifications. I'd like to acknowledge the support of my advisor, Dr. Elliot Britton, and the University of Toronto Electronic Music Studio, where I recorded this piece. And here are my works cited. And that is it.
In the interest of time, I just would like to take one question if there is one, and if not, I would like to move on just because we have 9 presentations today and time is running short after the technical hitch. Is there one question? Okay. I think you're off the hook. I did want to mention that you talked about the idea of heaviness, and there's quite a few people who have done psychoacoustic research into that. And I think, as you said, that it's different for different people. So
yes.
So it's like that's actually a cool thing that needs to probably be explored more. So.
Great. Thank you so much for the time, and sorry about the internet issues. Thanks so much.
Not a problem. Thank you. Okay. So next up is Sangbin Rhie, who is at Seoul National University of the Arts here, and had a paper last year as well. And his presentation this year is interpreting the output signal of nonlinear transfer function system based on power function n, which, wow, that's a mouthful. I'm going to leave it up to you.
Okay, can I start with, do I have to speak to this microphone? 마이크 대리라 오디오랑. Okay, and I'll start with my brief introduction to myself. I'm Sangbin Rhie from Korea National University of Arts, and I'm majoring computer music theory in schools. And the topic we will discuss today is extreme cases of non-linear wave shaping. As you guys know, a simple case of wave shaping is being usually discussed based on only power function and single sine wave as an input signal in many textbooks, such as like Dodge's computer music. We will now talk about wave shaping synthesis with complex tone input signal and nonlinear transfer function system, which is quite tricky to figure out what's going on inside. Before we start, I have to give two brief notices to public, and I have to warn you guys because my presentation for today has explicit mathematics, which is an extremely pleasant way to start Holy Sunday morning. So for people who are allergic to math, especially calculus, feel free to take a brief snack break or feel free to stretch your arms. I'll never blame you guys for not paying attention. And another one is my English sucks, so I'm watching my presentation script every second, so please forgive my English linguistic ability. So, okay, anyway, let's start. The simple case of wave shaping involves single sinusoidal input and simple power function as a transfer function like y equals to square of x or cube of x. Or the transfer function can be a linear sum of several power functions. Since I suppose all of you are already an semi-expert on sound synthesis theory, so I'll actually skim through the simple cases of wave shaping synthesis. Okay, here you are. You're watching two formulas on the screen. These are the results of simplest wave shaping, which input signals a single unit sinusoidal wave which has amplitude value of 1. And transfer function is odd or even power function. First case above, number 1, describes even power functions case, and second case below describes the odd number power functions case. You see, it's 2n refers to even number, and 2n plus 1 just refers to odd numbers. Okay, I used sigma notation to add all the resulting partials as of wave shaping. And in proceedings, I cited some examples by calculating the result of wave shaping with given formula above on the screen. And formula 2 in proceeding is the process of calculating the system, which can be described as a transfer function fx equals 2 x plus square plus cube plus 4th power and 5th power, and you can just see the proceedings because it's a bit nasty calculation. And for sure, the tone color, which means the partial structure, overtone structure, may vary upon the distortion index, which means the input signal's amplitude value, as you already know. Also, the resulting signal will be always harmonic when you use this method. Okay, let's move on to slightly trickier cases of wave shaping synthesis, which is the main topic we're going to discuss today. Let's consider the input signal has more than one partial, and let's just call them a complex tone, which is the easier way to name this. I've calculated the simplest case of complex tones wave shaping with transfer function of y equals to x squared, and it's written on the screen like this. There's why interpreting complex tones wave shaping is complicated. Intermodulations, which means ring modulation of two simple sine waves. That kind of thing occurs when we calculate the power of the complex tone like this. And this intermodulation, this term is suggested by Miller Puckett in his book called The Theory and Technique of Electronic Music, I remember. And this is the artifact which makes interpretation of complex tone wave shaping tricky. And we should introduce another method to make this interpretation process easier, and that method is called polynomial theorem. Polynomial theorem is a theorem's trigonometric function, a cosine function version, which x, variable x is replaced by cosine function is cited on the screen like this. it's quite nasty, but I'll explain it for you. If we use this theorem, we can calculate the coefficients of every terms, and I have calculated the complex tones wave shaping result of system, which is transfer function of y equals to x is cubed, which means third power. And this time, the complex signal which I brought has three partials. And you can look proceedings formula 5 to formula 7, and you can see my torturing process of calculation, which brought me tears every several nights. As you see, it's still uneasy to calculate the total partial occurring as a result. However, we can shorten the calculation process much more than raw calculation with this theorem, which means this theorem will be quite not unfamiliar with you, so I'll briefly explain what this does, and I'll just use whiteboard to explain something. For example, if we have to expand this one more. If we have to explain polynomial like this, we just have, if we don't know that kind of theorem, we just have to make the calculation by just simply multiplying every 6 x minus y's, and it's just a terrible process. However, if we use that theorem, we can figure out every term's coefficient. Let me just write the literal result of this calculation. Okay, we have 1, 2, 3, 4, 5, 6. 7 terms in this result, and all terms exponents are we'll consider this 1, and x0 and y0. The summation of all exponents are 6, and this means, in this case, I brought 3 partial case, and this means p plus q plus r, all the exponents, summation equals to n. In this case, p plus q plus r equals to 3. By using the theorem, we can figure out all the coefficients in front of every term. Same color. Fine. We can figure out this term's coefficient is 1. This minus 6, 15, minus 20, 15, minus 6, and just 1. We can figure out all the coefficients using that method. So it will be easier to smack down the result into several linear summation of cosines and power. So it can just shorten the nasty process of raw calculation like this way. We can just briefly shorten that, but the calculation can be remain slightly nasty, but that's still a good news to use since we can make it short. So it will be helpful for someone to want to calculate the resulting signal's partials. I think that kind of people will not exist, but it's still still interesting thing for me as a DSP geek. Okay. Let's move on to more specific situation, which input signal is harmonic in all overtone structures and all partials having same magnitude value. These kind of situation is notated upon the screen like this. All the partials having same magnitude and all harmonic, beta, 2, 3, 4, 5, 6, like this. And you can imagine more extreme cases with like 100 partials, but I don't recommend. Okay. We can find some rules among the coefficient appearing as a result. We will start from harmonic complex tones square, the simplest case notated on the screen. Let's just write the coefficients only, like this way. The rule I found starts from the centermost term, which is written on red number and slightly underlined. And I found the steps among every coefficients. The centermost term, which is 2, minus 1, it makes 1, and plus 1 makes 2. And you can find the rule minus plus 2, minus, the 4 minus is in plus 3, and 5 minus 1, 3 minus 1 plus 3, and 4 minus 1 plus 4, and 5 minus 1 plus 5, and we can find a simple rule. Let's look at the left side, and minus 1, always minus 1 appears in the left side of the centermost term, and the rest of the left side is filled with step value is filled with plus 1s. And if we draw a partials magnitude graph with these datas, that will look like this. Maybe if the partial grows more than like 10, 20 to 50 to 100 partials, maybe it will look like a fractal-like shape. I just only calculated this 5 cases and just made with graph. But if you have time, you can calculate more extreme cases and you can contact me with email written on the proceedings. Okay. In case of the cube, I also notated only the coefficient values. It is this case's rule is more complex and complicated to find out, since we have to find out the secondary step value. And secondary step value shows the definite rules. So I'll explain the second. I explained the rule based on the secondary step value. In this case, we don't have to find the centermost term, but the rule starts from DC components value, which is the rightmost term. Just don't mind the step value around the DC component, and just see the simple small numbers, and we can find the rule easily. We can find 1 plus 1. Firstly, we have to fill minus 2, which is presented with dotted line below, and fill rest of the place with plus ones, right? 0 plus ones, 1 plus ones, and 2 plus ones, and 3 plus ones, and 4 plus ones located between the rightmost term of secondary step and -2. And next, fill plus 1 plus 1, and 2 plus 1, and 3 plus 1, 4 of them, and 5 of them. Fill the plus 1s and locate -5 and plus 4 beside them on the left side, and fill the remaining spaces with -2s. If we draw this data into graph like before, it looks like this. In this case, this doesn't fluctuate like this. It just drops simply, like drops kind of bit exponentially, I think, but it's actually not. We can't call this exponential, but the shape looks similar to that. Like slope of maybe some filters, audio filters, which doesn't have a ripple. Okay, maybe if I were a greater mathematician, I should find the general rule and make the formula of all harmonic complex tones wave shaping result, but I wasn't able to do that. So I calculated the data and made graphs to just give you DSP researchers to get a hint for harmonic complex tones wave shaping. So maybe this will give somebody a help. I hope. And I'm just suggesting you a method and a data today. Okay. Lastly, I want to introduce a nice method to smack down the nasty non-linear transfer function into a linear sum of power function of x. This powerful method is called Taylor series, and the special case of Taylor series is called Maclaurin series. Yeah, this is the final part of my presentation for today. If function, this means transfer function, can be differentiated at x equals a, and if a is in a field of real number numerous times, we can approximate transfer function to a form of polynomial, which is a linear sum of x, like this. And especially if a is 0, we can call Taylor series a Maclaurin series. Then the Taylor expansion will come in handy than before. And this is an example. If we expand sine function using Maclaurin series, it will look like this. You guys will always have learned this factorial symbol in high school, or okay, someone should forgot it, but this makes really interpreting nonlinear transfer function easier than before, because you can just insert cosine function into a place of variable x, and this complex tone can be interpreted as a linear sum of the power of cosine functions. Okay, if we know how to use Taylor or Maclaurin method, we can guess what will be the output signal of frequency components of the most nasty transfer function system, such as this kind of transfer function, which seems really kind of nasty because it's a cascade of two nonlinear functions, and it's parallel with linear function, and the resulting signal looks like this. It looks like a torn can of baked bean cans, which is torn off with a cutter, and you can usually see this shape on recycling places or trash can. If we expand this nasty function with Maclaurin method, you can get this polynomial, which is a combination of power of x. So you can get the result. You can get the result easier than before. You can guess which partial will come out from this transfer function system. And I've calculated numerous cases and proceedings, and since I don't have many times, I'm just skimming through my presentation. But if you want a specific result, you can look at my proceedings. Since it is written in Korean, but all mathematical formulas are written thoroughly, so you can just look at them, and if you have further questions, please hesitate to mail me. Okay, this is the extreme case, and I brought super collider codes, and I'll show you what this waveform sounds like. And let's boot a server. Okay. This is a scope and frequency analyzer. Is there any maybe out? Okay. Then I have to put a server again. Maybe there will be. I don't know what's happening, but still not making. Is this volume muted or something?
그거 맞아요.
사이즈 같은 거 하면 돼? 사이즈
잘 나오잖아.
Okay, I'll just try rebooting the server.
Or maybe quit the application and then reboot,
Yes,
relaunch.
close the,
Okay.
yeah.
Because the settings
That's
changed.
the best way.
Okay,
어.
Simplex.
Good.
Okay, due to the technical problem, I wasted like 1 or 2 minutes, but it's
You're okay.
almost over. Okay. briefly, and I'll play it for you again. It's actually I made my school's electronic music studio's door-like sound with wave shaping, and it's exactly the waveform of this, and I'll show you scope again, and you will understand what I mean. Yeah, you'll see. Can magnify. Yeah, you'll see some waveforms that looks like exactly same as a waveform that I suggested. And there are some super collider wave shaping codes in my proceedings, and if you have time, you can follow my codes and make your own wave shaping distortion synth sounds. And yeah, I hope you use some wave shapings in your pieces, electronic music pieces, in further pieces. So yeah, that's end of my presentation, and if you have any further questions, at this time, please don't hesitate to ask.
Any questions? Yeah, go ahead.
Okay.
So when you're doing the Taylor series expansion, you're basically estimating the transfer function, right, of a complex signal?
Yeah.
So then, does that, like, I don't know, like, does that help you computationally, like, if you're doing DSP, if you can, like, process in the frequency domain then, or, like, what's the purpose of doing the Taylor series expansion?
Just I wanted to know what overtone, what partial components will appear as a result. I was curious about that, and I thought this will be easier to expect the components of resulting signals partial rather than doing an FFT.
Okay, so yeah, it's basically a way to see the signal
Yeah,
in the frequency domain. Okay, awesome.
Yeah, go ahead, please.
I'm wondering about any artistic applications of this yet. Do you have any pieces that you've used this in?
Actually, I'm trying. This was my paper for last semester, and yeah, I'm doing some musical experiment with wave shaping synthesis recently. So maybe if I complete writing the piece using wave shaping synthesis like this with this extreme transfer functions, maybe I'll contact you. Yeah, not yet. In conclusion, not yet. Yeah.
Can you change that? I just want to hear that steady, that acoustic sound, but the perk method
Okay.
and the
Maybe just get rid of.
yeah.
Sorry. Let's put something. Am I doing something wrong?
scale of some sort is different from what it was when it.
It's running.
It doesn't contain any errors, but
Right. It's weird.
Or
I'll try it.
That's fine. Yeah, I just curious.
Okay, there's not a critical error, but I'll just show it to you during the refreshment break. Okay.
Any other questions? I'll add one quick thing. It seems to me that the cool application of this is you can sort of design the spectrum that you want and then calculate the transfer function so that you could sort of match your wave shaping to some kind of external sound by looking at its harmonic structure and finding a transfer function that creates a similar result. So it's actually kind of cool. But, I mean, that cool future application. So, cool. Okay, thank you very much.
Let's share. I'm just going to make sure I'm sharing the right thing.
Okay.
You're sharing like the whole window of, yes, you're sharing the whole window of the,
Well, right now, when I look on the YouTube stream, I just see my big face on the camera, but I would like to make sure that I'm not just broadcasting my notes.
Right.
Okay. Well, I believe I'm sharing the right thing, so I can get started at any time.
Would you want to try any like audio sharing or something? The sound?
Yeah, I can go to an excerpt that has sound. Let's see. How about this? Oh.
Are we supposed to
Very
hear?
good. You get anything now?
No?
no.
No, I have, well, let's go back. In Skype, let's see, I don't know what I'm supposed to have as my output device other than my audio interface, which is broadcast. Do I have to do is share my sound as well, as in Zoom?
Yes, you will have the button when you receive the call from me. You will have the option to sound share.
Okay, then in that case you need to call me again because I don't remember clicking on any button for sound share.
Okay.
Or is it next to the microphone?
Given the prevalence of creative coding and the increased presence of algorithmic media in everyday life. The main topic here is generative electronic music and the way that it intersects with the construction and the use of new musical instruments. This has been a meaningful space for combining my own interests in composing computer music and improvisation, and in terms of thinking about what instruments can say about living in a digital culture.
Could you please introduce yourself briefly, because I didn't get a chance to do that, and
so... all right. Yeah, my name is Michael Lukaszuk. I'm based in Kingston, Ontario. I teach electro-acoustic music and music technology courses here. I've been at the Teams conference before a couple of years ago, where I gave a presentation on a kind of glitch toolkit I wrote in Chuck, but now I'm going to be talking about instrumentality. So, right. So, before getting into specifics about what musical generativity qualifies as and what a generative instrument might entail, I think it's useful to discuss the cultural environment that encouraged the possibility of generative instruments. So, musicians have been generating material out of rule-based systems for some time. There's the use of canon, for example, in the Middle Ages and Renaissance. In non-Western or non-classical traditions, there's kind of nested, what's called colotomic rhythmic cycling and gamelan music. And even in earlier computer music, there are pieces such as the 1957 Iliac Suite, which lay a nice foundation in the way that it connects performance and algorithmic process through the use of a computer-generated score. So the point here is that algorithmic processes are not new. They hold a firm place in many approaches to music creation across a variety of eras and genres. So what is new is that in recent decades, the ability to store and produce audio using digital technologies affected a shift in which not only the methodology, but musical instruments themselves could possess a kind of generative nature. In other words, we can embed algorithms into a device and make it or its interface into an instrument and interact with the musical object through learned behaviors, much like standard techniques of a concert instrument. The emergence of musical instruments with generative capabilities is a unique shift in instrumentality, as they often extend from the functional nature that digital objects hold in our everyday lives. So rather than having objects luthered specifically for expert music performance, generative music sometimes features an extraction of an instrument from a digital device and or software that is distinct also from the use of things like found objects for musical purposes in 20th century pieces by composers like Cage and Coggle. The score excerpt here is just from Cage's Water Walk, showing the use of found objects as sound material alongside instruments. So the fact that websites and mobile phone apps can store and or become instruments can be thought of as a creative response to the way that computing has become ambient in many homes and social or educational settings. This idea of generative music as being of instruments lies in tandem with the gradual need to figure out how we can proactively interact with computers in increasingly digital surroundings. In its dual capacity of functional technology and expressive object, generative instruments, I feel, can be positioned closer to folk instruments rather than kind of ornate, masterly luthiered instruments such as this Renaissance lute meant for specifically for concert performance. So as an example of this relationship between folk and generative instruments, we can look at something like, I have an example here of a legawka, which is a Polish instrument used for agricultural purposes such as herding. And I feel like in that context, it can be extended to be into a mobile phone app as a generative instrument, often emerging from functional needs such as network communication. So without diving into a deep end and presenting an entire new taxonomy for digital instruments, I would like to mention what kind of instruments I'll be talking about as generative. I'll be drawing on my own research creation work, including instruments that I've made for laptop ensemble, and I'll also be focusing on instruments from work that I admire or find interesting. So these include programming languages that are played within a code as instrument paradigm, mainly demonstrated in performance through live coding, but also as instruments used to realize computer music compositions of many kinds. An example that I've posted here on the left is a chuck-based code instrument called the Metamando, which I wrote for simulating a giant mandolin. There's also desktop and mobile phone apps, such as on the right here, I have an app called a Gestrument, which I did not make. It's by Jesper Norden. It's generative in the way that it incorporates evolving automated processes that are triggered by haptic interaction with the user interface. And as a kind of third category, I think we can think of software that makes existing instruments generative. A good kind of example of this is George Lewis's Voyager, which is not necessarily a generative instrument, but can imbue instruments with a generative nature. So the term generative music first seemed to gain popularity through its use by Brian Eno, who introduced the idea to a wider public for his talk at the 1996 Imagination Conference, hosted by Hotwired, which was the first commercially successful online magazine. Albums such as Eno's ambient music series present a process-based electronic work that lack a sense of goal-orientedness and serve as a natural precursor for the kind of generative computer music that was driven by the availability of laptops and related digital technologies in the 90s and early 2000s. Eno's discussion of this kind of music, both in his 1996 talk and in later essays, tends to cycle through various characteristics of generative music without landing on a firm definition. His published diary, A Year with Swollen Appendices, describes his use of machines and systems that could produce musical and visual experiences, but this could be used to discuss a variety of music that blends indeterminacy and technology. I also think that it's important to avoid the possibility of creating an interpretation of such an expansive approach to music making while focusing only on a single artist. Eno kind of has a gravitational pull when it comes to becoming the representative artist for certain genres. So if we're going to start thinking about big musicological themes such as instrumentality, we need to broaden the historical network of artists who have contributed to the development of generative music. For example, composer Laurie Spiegel provided an early example of human improvisation with a software-based digital instrument with Music Mouse from 1986, almost a decade before Eno spoke at the Hot Wired Imagination Conference. Music Mouse connects generative music as being performable and of instruments in that the use of the computer's mouse position allows you to produce patterns that affect parameters such as register, chord spacing, and so on. This is just more than a mere recording of a generative process as part of the studio assembled composition. It becomes an instrument in the way that you can accumulate techniques for playing a generative process. I do have a video example of Music Mouse, but there will be no audio. I think you can find excerpts of it online though. I won't continue with the video though, since there's no audio.
Maybe you could send me the URL, then.
I worried about bouncing across too many screens and things getting a bit clunky. So look up, it's in the conference proceedings, and I'm sure Music Mouse videos exist online. So to comment on the proliferation of this approach to music making rather than being of one artist, in recent years, generative music, we can say, has grown further out of the Eno orbit in the proliferation of practices such as live coding and musical AI. For those of you who haven't heard Daddy's Car, it's a pretty impressive AI rendition of the Beatles style by Sony's CSL Labs. Considering the variety of such approaches, I will try to establish generative music with my own makeshift definition as music that is facilitated by the ability to store instruments and systems using technologies with evolving constraints. In an attempt to test this definition, I'd like to go back to my Metacommando chuck-based instrument. So it's not just the ability to impose algorithms that automate behaviors such as rhythms or musical motives played over time. The Metacommando connects to the constraints aspect of this definition because the simulated features of the instrument are also in a state of flux, such as the body size of the simulated instruments and the number of strings available. Okay, so why might instrumentality matter when talking about generative electronic music? Why do we even need to talk about this? The musicologist Philip Albertson focuses on how the becoming and use of instruments shapes the taxonomies of musical genres. He uses the example of Bob Dylan's 1965 performance with electric guitar at the Newport Folk Festival and how it challenged notions of authenticity and genre norms in folk music. So similarly, contemporary genre norms and performance conventions can be disrupted by generative music and its instruments. An example of this is collaboration between Brian Eno and Coldplay for an app that works alongside their song Hypnotized. So this edition of this app, as part of the ensemble, challenges the traditional audience versus performer distinction in rock band concert performance, moving towards a decentralized form of performance, which is somewhat unusual for the rock band setting. In his book, Sonic Writing, computer scientist musician Thor Magnuson writes on the emergence of instruments out of digital devices, discussing how young people often enter the world through digital technologies such as apps and games, and how these digital systems become instruments through knowledge that is accumulated in their non-musical context. This point of view highlights the importance of reconfiguration and mutation in the transition or extraction of musical instrument from a digital object. In other words, where a tool may be useful for transmitting a message or facilitating a task, we can use musical practice, including wrestling with genre and positing on performance practice to make the app or the code we write into musical instruments that are creative ends in themselves. In projects as far back as Spiegel's Music Mouse, or in recent mobile phone apps such as Brian Eno's Bloom iPhone app, digital instrument designers are leveraging swiping, typing, pushing, and clicking to accumulate new kinds of knowledge expression akin to the different kinds of bowing articulations that you might find on a stringed instrument. So These are just excerpts of, you can actually, if you play the Coldplay song and find the video of the Generative app that, you know, collaborated on to work alongside of it, they do mesh this quite well together. Writings on our interactions with digital systems and broader cultural spaces can help us understand the importance of learned behaviors and how understanding digital objects as musical instruments is an exercise relevant to living in digital cultures. So media scholar Tanya Booker's 2018 book, If Then, discusses aspects of power in politics and algorithmic media, such as Facebook's and Google's search engine and social media algorithms. So in discussing this, Booker emphasizes the significant role that users have in configuring the algorithmic spaces that they themselves inhabit. For example, using specific language to amplify social media posts. In his 1996 book, the MIT Media Lab founder Nicholas Negroponte echoes the significance of reconfiguration, in being digital, he argues that the real opportunity comes from the digital artist providing the hooks and mutation and change. So this focus on digitality as conveying process and projecting a single or collective imagination again extends well beyond the mobile device app work of Brian Eno, in which not just the Coldplay experiment invites audience input through generativity, but experiences such as their 2018 partnership with Microsoft to create a mixed reality version of the Bloom app, play with the ideas here in Booker and Negroponte. So yes, there was a 2018 collaboration in Amsterdam in which, you know, there is kind of multiple performance spaces and singular versus group efforts conveyed through the Bloom app. In his book, Understanding Digital Culture, the sociologist Vincent Miller presents a set of characteristics that define digital media. These are networked, interactive, hypertextual, automated, and database. This framework used by Miller suggests that digitality represents a paradigm shift from older forms of media that can be applied to generative musical instruments to understand new ways about thinking of instrumentality, ways that create space for mobile apps, languages, and the like. So in extending Miller's approach to thinking about digital media to musical instruments, you're offering an alternative to the classical organological approaches that are essentially incompatible with generative musical instruments due to their focus on physicality and source material as the basis for categorization. Basically, we can use these criteria that Miller presents as new variables for differentiating instruments used to make generative music, since the classic organological systems we encounter in things like Western conservatories and libraries tend to work with physically fixed instruments, not variably physical instruments, which are typical of generative music. So, in terms of networks, the key here, I think, is not the fact that certain instruments for playing electronic music can be connected to the internet, but that they can be formed into a decentralized instrumental network. It's significant that in performance practices such as laptop ensemble music, there's an opportunity to view the patch or the language on a local level and as part of an accumulated meta instrument. Miller's idea of a pyramidic older media, such as broadcasting, is akin to concert instruments as a one-way transmission device operated by an expert. So some of my own research creation work that is focused on extremely accessible, albeit technologically inelegant ways of facilitating network performance with digital instruments include this Code, Sound, and Power instrument project that I developed in 2020, which is a laptop performance instrument that accumulates RTC mix scores that are contributed via MaxMSP's MiraWeb and a VPN, and played through a central kind of MaxMSP hub instrument. So here's an example of this instrument. This is the user's ability to transmit the scores through RTC mix and the accumulation of them in a hub via MiraWeb and a VPN. interactive. So it's obvious that interactivity is a pretty big theme in computer music. Rather than debating over what constitutes reactive versus interactive, Miller focuses on the way that interactivity is fueled by user needs. In terms of the manner in which interactivity has fueled my own user needs with digital music technologies, I've relied on interactivity with generative instruments for teaching about electroacoustic improvisation. It's often challenging to have electroacoustic music students focus on texture and timbral elements within the musical foreground rather than the motivic or harmonic devices that are commonly emphasized in other music classes that might foreground major minor tonality. So in this sense, the interaction with the custom user interface to activate generative behaviors links to interactivity and links back to Alfredson. You can say that the manner in which interactivity is approached reflects musical values that amount to genre norms. In my paper, I do discuss a couple of the laptop instruments. They're basically just standalone Maximus Piafs with generative features and user interfaces that can be manipulated in a scalable way for electroacoustic improvisation in a group. Hypertextuality is useful for our purposes because it's the place where a digital instrument, despite its inherent physical variability, can be understood as a text, a way of writing about culture. For Miller, this kind of textuality is achieved through multiple streams of interaction with digital objects and contributes to the unique nature of the generative instrument as a kind of palimpsest with ever-changing authors. This is most visible in data-driven instruments that are generative in their use of machine intelligence to wade through genre and performance practice data to realize music. A good example of this that I admire is Arne Eigenfeld's-Jesny, the generative electronic statistical modeling instrument, which produces electronic dance music in genres such as house by analyzing a corpus of human-made transcriptions of existing tracks. This instrument can be considered automated in its capacity to make sounds without human intervention, but I would like to consider the act of transcribing musical parameters and the implicit bias that comes with such an activity as a kind of playing outside of real time. The transcription aspect is what relates Jesny to Miller's proposed idea of hypertextuality in digital media. So while the resultant EDM tracks produced by the instrument make the manner in which the system draws on various transcribed elements is based on the use of probabilities to move between comparable sounding elements such as bass lines and drum patterns. In this case, the body of the instrument is the material that Jesny learns, which is variable depending on the approach to transcription. Miller discussed of automation in digital media of the majority of human labor as can be experienced, for example, in arpeggios played by a sequencer instead of a keyboardist. Automation is a necessary component for utilizing the components of generative instruments. The vast corpuses of data needed to play an instrument such as Jesny will be automation. In instruments such as Jesper Norden's Gestrument app, it is the fact that the performing of automation amendments with the instrument that matters here. The swiping, the tapping, and interacting with the instrument in its libraries are kind of the way that we can link a generative musical instrument to Miller's framework in automation. So I'm just wondering about my time constraints here. It's a video of the gestrument. Finally, we have database. While early broadcast media involves cycling through menus on a smaller scale, what Miller is getting at with database is the manner in which digital media allows to navigate large databases with tremendous ease, again, due to the pairing with automation. So Lewis's Voyager system is a great example of a database generative instrument in that it imbues instruments to become generative, such as a disc clavier or a synthesizer or a MIDI VST library. There are versions of Voyager that use
Canada Netflix time. Okay, you're back.
Are we still good? Am I still projecting?
You're projecting, but you left the room for a little bit. Internet connection issues. Could you go ahead and just start?
Did I leave off database?
You started talking about Lewis's Voyager, and then it kind of crapped out.
Right, all right, so I'll go back to where I started talking about Lewis's Voyager. So it's a great example of a database generative instrument as it adapts to something like a disk clavier or a synthesizer or a MIDI VST library to kind of assign generative capabilities to those existing instruments. There have been versions of Voyager that use large collections of MIDI versions of traditional orchestral instruments combined with instruments from South Africa, South America, East and Southeast Asia, and the Middle East to form a virtual orchestra in which the makeup of sections is in a constant state of flux as the software recombines and silences parts. In a 2005 interview with Bomb magazine, Lewis relates the idea of having a large number of software players that can play any instrument at any time to his activities with the Chicago-based Association for the Advancement of Creative Musicians, or AACM, which explored free improvisation in a way that broke down boundaries between jazz and experimental music, according to their motto of great black music aimed into the future. The AACM's multi-instrumentalism was augmented in the software domain with the Voyager system's occasional use of large improvising orchestras. In this interview, Lewis mentions, "I don't know of any culture where you can get 100 people together, each one of whom can play 100 instruments, and they get together and they improvise." And that is the political subtext to this setup. It's based on both the appreciation and the rerouting of the classical orchestra model. Okay, so I'm going to skip ahead to, this is just a couple excerpts of Voyager, and we can talk about, kind of the previous aspects of classification. So looking back at attempts to integrate electronic instruments into ornithological frameworks might help establish the value of drawing on source from media studies such as Vincent Miller's framework for digital media. In the 20th century, systems for classification of instruments, at least in much of the Western discourse on this topic, consisted of responses to this 1914 text, Classification of Instruments by Erich von Hornbostel and Kurt Sachs. So this used an approach that focused on the physical materials that were used to make or perform on an instrument. As electronic instruments were not in wide use around this time, it's understandable that these categories are dependent on acoustic instruments with vibrating bodies in physical space. But there are mid-century attempts at responding to the emergence of new electronic instruments, such as the theremin and Oud Martineau, including electrophone category in the Hornbostel-Sachs system, and a section of Sachs's 1940 book, The History of Musical Instruments, in which he includes some more information on categorization of electronic instruments, but I don't think it really represents a good faith effort to integrate them into the existing framework of idiophones and aerophones and so on. Sachs writes, surely these instruments owe their existence to the experimentation of electro-engineers rather than any musical need. So I don't think there's a good effort to kind of really integrate them into the 1914 framework or the extension of it that he presents in his 1940 book. So an update to this kind of classic ornithological system took place in 2011 with the Musical Instruments Museum Online project, in which there is kind of significant addition of electronic instruments such as the mellotron. But the issue with this kind of top-down system is that the construction of digital instruments can be quite varied and malleable, and there's really no way to account for it with this framework. So part of my research on generativity as related to large musicological themes such as instrumentality and performance practice has been to kind of bridge the gap using materials from ethnomusicology, such as classification systems from oral traditions. The image here is from a framework presented by the ethnomusicologist Margaret Cartamy in her book on concepts and classifications of musical instruments. It's a West African approach to musical instrument classification that incorporates myth and mode of transmission to the human realm, along with spiritual and historical factors such as use in ritual ceremony, which I think is much more approachable for something like generative musical instruments rather than the hornbostel sax system. So just due to time constraints, here's another example of a West Sumatran ornithological system presented in Cartamy's book, which includes things like the player's musical position in the framework. I've adopted and kind of used the Cartamy's West African presentation as a jumping off point for a possible organological model for generative musical instruments. This one here is for my pulsar instrument that I developed for electroacoustic improvisation. Similarly, this one is just me, and I've also related it to Voyager. So as a final note in my paper, and I thought I might as well include this in my presentation, I talked about the kind of algorithmic gamelan as kind of interesting phenomenon in computer music that relies on generativity and instruments. So the digitization of gamelan music leads to important considerations about whether computer technologies and instruments that hold significant cultural weight and in fact work symbiotically with each other. The Indian cultural theorist, I honestly can't pronounce the name, but it is there, writes that about like an indeterminate third space that can be achieved through hybridization. And there are other kind of research efforts on hybridization of traditional instruments in computer music, such as Jeff Roberts' work, which kind of talks about how timbral usage of traditional instruments can inform technological practice with electroacoustic music and related devices. So two examples that I find particularly interesting of algorithmic, if not generative, gamelan from contrasting sources include the Virtual Gamelan Graz project, which deals with hybridization of gamelan and musical programming to form kind of algorithmic supercollider-based instruments for kind of digital gamelan performance, and apps for pedagogical purposes developed by, there's a gamelan research project group out of Dian Nuswantoro University in Indonesia, which focus more on kind of cultural preservation rather than kind of bridging the gap between computer music performance practice and gamelan. While I don't use gamelan myself, I've kind of wrestled with similar issues in improvisation with traditional instruments alongside computer music devices and objects. I can play, actually, we don't have audio, but I've used instruments such as kalimba in live coding performance as a sampled source, and similar ideas of hybridization as whether it's a third space for kind of looking at how, in Robert's view, traditional instruments can inform performance practice in a technological setting, or whether or not it's cultural resourcing kind of come to the foreground. So I expanded kind of give examples of not just the Virtual Gamelan Graz, but other kind of related wrestling with hybridization of the gamelan in my paper, but I think that is going to be it. So thank you for listening. Happy to take questions.
Okay, we're cutting a bit into our break, but if there's one or two questions, I think we could. Yep.
Yeah, hi. Can you hear me? Okay. Should I go?
Yeah. Do you want? Can you hear him? No. Go forward the mic. Can you hear us?
Yes.
Okay.
Hey, how's it going? I really enjoyed your presentation. I'm very much interested in this sort of new organology, or like the way in which it's being sort of broken apart through digital. Wondering if you have looked into the work of Bert Bongers, who is also kind of classifying the successive technologies and how they inform musical instruments. I found it very helpful with my own work with interfaces. And I just wanted
Is that the one that's based on cybernetics?
Yes, it's sort of in the science and technology studies realm, and it kind of just clusters things as they progress in as successive technologies, and how acoustic, like traditional organology, like the horn Brussels sax system kind of gets attached to technological advances like the transistor. And but I would just wanted to say I really enjoyed your talk because it kind of fits in really well with some of the research I'm doing with the language of interfaces.
Great. Well, thank you. Please connect with me. I would love to read what you're up to.
Yeah. All right. Thank you.
Yeah. There's also, I would really like to recommend the music theorist Jonathan D'Souza's book on, it's called Music at Hand, and it covers a lot of interesting ornithological topics, including an approach based on cybernetics that's really interesting.
Okay. Anyone else, or we do a break? Okay. I guess that's it. Thank you very, very much. I will let you go ahead and introduce yourself as part of the presentation if you have details. Your paper is generating sounds using Simplex noise algorithm. And I guess we should test if your screen sharing is working.
Hi.
Can you hear us?
Can you hear me?
Yes, we can.
Yes, we can hear you.
We can hear you.
Okay, then can I?
Yes, would you wanna share your
Yes,
screen?
Anna. Can I get?
Is
Are you working on it?
Oh, there we go. Yes. Black screen.
Yes, we got it.
Got it.
So can you see?
Yes,
Yes,
we can
yes.
see your screen.
Okay, then let us start. So my name is Masafumi Oda from Tokyo International South Articles Institution of Japan. So let's get this started. Campbell developed new noise algorithm called power noise in 1985. Then he upgraded that to more sophisticated algorithm, which is called Simplex noise in 2001. Simplex noise has been often used in the field of computer graphics. As opposed to simple random value, it can be used for generating very simple random values. And Pauling noise and Simplex noise. Now we are going to take a quick look at both Pauling noise and Simplex noise algorithms. Pauling first developed the noise algorithm, which has been called gradient noise, or classic Pauling noise in 1985. The most remarkable feature of this noise is that it generates very smooth, continuous random values, unlike simple random noise. Stefan Stanton described the cancer of this noise. He said that Pauling noise is so-called gradient noise, which means that you set a pseudo-random gradient at regularly spaced points in space and interpolate a smooth function between these points. However, according to Pauling, this algorithm has following shortcomings that could be particular consequence in a real-time setting and in a hardware implementation. 1. Lack of single standard reference implementation. 2. Requiring many multiplies. 3. Visually significant unsolvability. 4. Gradient artifacts. 5. Difficulty of computing derivative. 6. Need for table memory. 7. Memory limited extent of the volume type. 8. Expense of generating to higher dimensions. And finally, lack of separation between signal and reconstruction. Since this paper is not our technical detail of Pauling noise, we don't get involved in that. Instead of classic Pauling noise algorithm, Pauling developed a new noise algorithm which is called Simplex noise. To generate that, he gave just following 3 steps. 1. Given an input point. 2. For each of its neighboring grid points, pick a pseudo random direction vector. Compute linear function dot product. 3. Linearly combine with some using a cubic S curve in each dimension, such as 3 times d squared minus 2 times 2 cubed as the interplant. And final gradient should be the permutation of this lattice. So this is the code of Simplex noise by WebGL. This is a very small image, so I will share the larger one. Please wait. So you can see this is a code of classical polynomials, and this is code of Simplex noise in JavaScript. So as Gustavson wrote, this code is unnecessarily long-winded due to our readability. The next one is written in WebGL by McEwan. Sorry, but so let's get next. If we want then a value from the simplex function, we can just load like this float value simplex noise open brackets backstory open brackets basic close brackets, and as we can see, once we define simplex noise, we can use just as built-in function. As a result, we can use this algorithms easier than before at cost level. And this is a patch of max MSB. So this next chapter is simplex noise in max MSB. Now we are going to take simplex noise in max MSB. That is to say, in sounds, we can get that each putting z dot point pft object and its attribute at what basis noise dot simplex. So this object can have many parameters, but main one the offset, which changes the shape of noise symmetry, and the scale, which changes the scale of noise. Manipulating these parameters, we can control most of this object. Then, how can we make sounds reflect simplex noise? One way we would like to take is to apply that to frequency bins values of some simple oscillators. S pixel has 0.0 to 1.0 value. So if we take 24 simple oscillators, and if each oscillator has 512 frequency bins, it is appropriate to regard this noise as a matrix which has 512 times 24 elements. To realize this idea, we wrote a code which stores each value in each buffer in JavaScript. In this code, we use for loops to write 512 real-time values into frequency bins of each buffer. And as each value always changes in real time due to manipulation of parameters, the consequential sounds should also change in real time. However, we will use another synthesis to change its pitch in order to exaggerate the final output. The final patch will be following. It is a part of the final patch. And then, so let us listen the outputs. I will share you the video, so please wait a minute. So, can you see the video application?
Yes.
The demonstration video?
Yes.
Thank you. And then, can you hear the sounds?
No.
No? Okay.
Sound sharing,
Sound sharing?
maybe by the, I don't know, by the microphone, is there an option for sound sharing? Or
Okay. So, how can I do it? So,
how large is the video? Is could you send the video by chat and we can play locally?
yes, it is the same video. I sent the same video.
Oh, okay, well, let's find it. Wait.
Okay, thank you.
Okay, yes, demonstration video. So we'll play that locally.
Okay, thank you. Okay, maybe it's enough. So thank you. And then let us back to okay, then so let us extend Simplex noise sounds to interactive expression with Unity. So finally, we will present an extended version which makes sounds and visual interact. We will use Unity, a game engine, for this purpose via OSC, Open Sound System Signals. In Unity, you can use Simplex noise in two ways. On the one hand, we write the code again in HLSL. This code is very similar to that of WebGL, so once we define the function, we can call it like built-in function. On the other hand, we use shader graph, a system of Unity, with which we can create shaders like graphical program language. So here's an example of interaction between MaxMSP and Unity, namely between sounds and visuals using Simplex noise. So please play my next video named maybe Psychedelic Psyche.
Could you play just a second for the video? Yes, the one, yes, that one. So this piece is, to be honest, a little long, so the conclusion. We are seeing how useful and what a powerful way the Simplex noise algorithm is in both sounds and visuals, since it generates very similar random values in very easy way. It can be used to generate new sounds unlike using traditional word randomness. Thank you. Okay, are there any questions? It's okay.
Hello.
Hello?
I wonder about the Tokyo International Film Art Cross.
Yes.
Yeah, what is that?
And it is an institution in Japan. We often publish
written about art or thought, and we often hold some concert or performance or some stage sometimes in Japan, mainly in Japan.
Thanks.
Thank you.
Any other questions? Okay, one more here.
Yeah, could you talk a little bit more about how you decide how far to move when you're generating the next sample? You said something about a weighted sum.
So like
from sample to sample.
Yeah, how you choose the next sample.
Oh, okay, yeah. How do you choose the next sample? Like from in the first video, you were changing you were changing different. The 2D graph of the noise was changing.
Yes.
How do you choose that? How do you choose that change from one noise to the one noise graph to the next? Is it random or user control?
Maybe I can't understand what you're saying fully, but in first video, what's the meaning of choosing? So I just using one object, and I wrote a code, and so what's the meaning of choosing?
Like parameter changes, like parameter.
Yeah.
Yeah. So what the parameters change the noise distribution.
Yes.
So how do you choose the parameters? Is that just user?
I see.
Yeah.
Thank you. Okay. So main parameters I just explained is offset and scales. I choose those because a scale is namely the scale of noise visually. So it changes the value of each pixels, and each pixel has the value from 0.0 to 1.0, so it can change the value of any value in sound. So I choose that parameters first on one hand, and second I choose the offset. These parameters also changes some, just offset of this noise, the origin of noise. So also maybe we can change it, then the visuals changes. So then of course the sounds will change. So I will choose this parameters. Maybe.
Okay. Thank you.
Thank you.
Okay. Thank you very much. We need to move on to the next presentation. Thank you.
my name is Alejandro Casales. I'm from Autonomous University in Mexico City. 안녕하세요. Guduri-chai. Cheneon Alejandro Casales-입니다. It's my first time with Korean and English. It's my second language. Excuse my mistakes. This presentation was timed and will not be necessary to interrupt it, please. As a self-introduction, I have been working with computer as an instrument for many years ago. I met Mueller-Puckett in 2004 and started to use pure data and Max MSP since this. I'm currently studying and creating some initial work for immersive spaces. So I'm going to present this research related to that topic, approaching to immersive sound perception through the ekphrasis. Okay. Immersion is an effect without physical matter that can be perceived by humans through their sense or the intellect. It has a universal and socio-cultural character that has been historically transmitted between different cultures. Consequently, it's a phenomenon that concerns our perceptions, and its effects and interpretations define its intensity and actions. The experiment that I will show for you consists in researching the introspective reflection through the ekphrasis produced by the immersive sound. Okay, the conceptual framework. This section exposes the relationship between the immersive sound perception, ekphrasis question around the research, and the ethical approach in the experiment. Immersion and its auditory perception are located in aesthetic, a philosophical treatise, and psychoacoustic phenomena, as well as improvisation mechanisms composed of surround sound and rhetorical mechanisms composed of transitional perceptions. Some authors propose that immersion can identify stimuli to depend and describe the sense of commitment of the viewer against the presentation system of technological artifact that produces it. From another perspective, immersion is a holistic concept that refers to its sound reproduction from different times, such as visual illusions on the walls of ancient palaces, optical illusions that decide the viewers through the perspective, shading effects, as well as panoramas, hemispheric projections, virtual reality mechanisms, and surround sounds. Along with this, it is possible to define that immersion is made up of different kinds of illusions that have evolved through the time with its technology, independently of the sense of perception. This means that perception cannot be conceived without an object that is perceived, and every object is made up of certain qualities that allow us to discern its shape, size, depth, color, tone, temperature, surface, and other sensations that stimulate response from our senses. Likewise, perceptual activity establishes a series of relationships between elements perceived from different natures composed of magnitudes, forms, transposition of time and space, anticipations, and frames of reference that change with the age of the human being. The whole process of immersion is a complex connection of human perception. In the psychological perspective, the immersion is distributed into cognitive levels, the perceptive and representative. The first level happens when sensation, attention, and perception are empowered through the caption of data. In the second level, our imagination, memory, and thoughts are connected with the senses. It can be anticipated that all auditory experience is mediated by imaginary illusions that shape sounds to localize them. Thus, it is possible to research into perceptual situation of identification and imagination. The philosopher Theodor Adorno wrote, the music image in the object world only appears scattered, eccentric, sparkling, and feeling. Likewise, Toru Takemitsu wrote, sound is an image no matter what the instrument or the composer does. Both authors expose a particular form of perception. However, auditory perceptions in their perceptive sphere produce different interpretative mechanisms. It has been proven that there is an analytical process for any language. The author exposed the knowledge in a holistic and transcendental sense, seeking through ekphrasis the sense of listening. There is on a transitional moment of introspection by the act of writing. In this case, the objective is to delve into auditory perception and the mechanisms for their measurement and interpretation. Therefore, an acoustic composition with an installation of 6 speakers create an immersive environment to measure their effects. The sound immersion comes from waves that can be defined by the psychical characteristics of the acoustic space with specific attributions. Their bases are given by monoaural and binaural signals. Afterwards, by the number of sources that can amplify its effects and differences. According to our hearing, an immersive sound can recreate our 360 degrees aural experience and extend the sounds to other perceptual moments from any direction. Likewise, an immersive sound replicates the oral experience and increases the spatial intensity. A unique aspect of immersion comes from the difference to the traditional listening in a concert hall, where the group of musicians and sound sources are located in the stage, frontally to the listener. In the immersive experience, listeners perceive the spatial moment of the sound. Immersive sound can be made up of a minimum arrangement of 4 independent speakers placed at 90 degrees and located in 4 corners for a quadraphonic sensation. The perceived dip would result in a bigger sensation. For broad spatial sensations, more speakers can help light sextaphonic sound trajectories. The hearing system inside the immersive environment provides us perceptual data and orientation. Therefore, the immersive experience allows us to analyze the interaction between the artifacts and human senses. Ekphrasis is an unconventional form of expression. In other words, it is a rhetorical resource that describes the encounter with the artistic artifact in any form. Its origins comes from the discourse and its troops. These figures can change the direction of an expression with another representation. Another definition comes from the rhetorical devices where the speaker evokes image in a mental world. According to Krieger, ekphrasis has its origin in the semiotic desire for the natural sign. The semiotic desire seeks the meditation with the perceived immediacy from an artistic object, as well as a desire that seeks the tangible, or better say, the transformation of what is aesthetically perceived. Theorist and art historian Oliver Groh defines immersion as an expression of literature, thesis, and ekphrasis. And as a literary studies understand it, does not have a specific grammatical form. Consequently, it needs to be defined by its content. Finally, a rhetorical device is a reflector of perception and a description with discourse and references that can be analyzed by researchers. Ekphrasis can be distinguished from other polysemic forms that do not have the similar capacities for interpretation and evaluation. As a result, ekphrasis can be a system to capture sensitive data of auditory perception, mediated by sound immersion and its aesthetic content. The analysis of auditory experiment have a qualitative assessment tool to produce representative data in a case study. The case study allows us to know a particular situation that we do not know. Another perspective proposed is an extensive research with a prevalence of a phenomenon. The case study is a way to organize data without losing the holistic approach. In other words, as well use different instruments and techniques to capture evidence. Their method is validated by triangulation of data. The triangulation conjugates the phenomenon with other perspectives. Their purpose is to validate the contrast with the phenomenon and other sources. As an example, there is a definition by the French composer Claude Debussy about his masterful composition La Mer Turquoise Symphonique pour Orchestre, or simply La Mer. He wrote his masterpiece between 1903 and 1905 during his stay in the British Channel in Eastbourne. With the example, the role of case study is not necessary to map the world, but to sophisticate its contemplation. For the purpose of the methodology implementation, data were obtained through an auditory introspection in order to understand the effects of surround immersion. In turn, 2 surveys were implemented. The objectives were to identify patterns of participants' consciousness, emotions, and perceptions. The first survey, named A, asks to reflect on listening, choosing 6 words from a list of 20 concepts related to auditory perception. The concepts were manipulated to express the moment of hearing and write an ekphrasis. The list of 20 concepts were categorized into perceptual, deep, closest, space, immensity, scale, loudness, immersion, distance, rhythm, noise, emotional, anxiety, harmony, longing, annoyance, incongruity, tension, and awareness, relaxation, tranquility, meditation, and peace. The second survey, named B, asks to reflect and write freely 6 words to express the moment of hearing and create an ekphrasis. The same question was put in service to implement the experiment. What do the sounds mean for you? It should be noted that 400 people agreed to participate in the study. A group of 200 people wrote the control survey. Another group of 200 people wrote freely. The question and the ways of conceptualizing the phrases helped me to find unexpected patterns to compare them into the results. Furthermore, it was announced that an installation with sextaphonic spatial location with an area of about 320 square meters was to be able to answer the surveys. In the installation, an immersive sound was produced at 51.4 decibels with an acousmatic composition in continuous repetition. The presentation of the composition was scheduled from 12 to 5 for 2 weeks in May. At the experiment, the health of participants' consent, respect for privacy, and confidentiality were taken into account. Therefore, personal information was excluded for the analysis. The qualitative data was used solely for operational purposes in the research. This is the place. This is some image from the people and the installation. Results. The resulting data had 400 individual contributions that were triangulated and 200 surveys were manipulated by a limited choice of these concepts of a list of 20. Other 200 were answered by a free choice. The purpose was to describe the variations and explain the meaning of immersive perception. The dependent variable was experimentally defined in the question because the prior situational conditions were not available. Even the result in the independent variable data was unexpected. Therefore, the interpretative faculties served to evaluate the revelation. Thus, 2 phases of analysis were implemented with different semantic categories of data collected. The first phase was the reduction of data through the use of standardized units, coding, and having the same information. Units is aggregated into perceptual, emotional, conceptionist, and the other were organized in the semantic process. Okay. As a result, Group A established the following percentage. 3.08% choose relaxation, 9.22% meditation, 9.04% deep, 9.04% tranquility, 8.25% peace, 8.1% immersion, 7.92% space, 6.72% immensity, 6.03% harmony, 4.22% distance, 3.96% loudness, 3.79% noise, 3.62% tension, 2.55% closeness, 1.72% rhythm, 1.55% incongruity, 1.38% anxiety, 1.12% annoyance, and 0.52% scale. Another group wrote 352 concepts with the following percentage: 7.6% tranquility, 5.9% peace, 4.4% relaxation, 3.4% C, 3.3% calm, 2.5% harmony, 2% nature, 1.9% waves, 1.8% reflection, 1.5% serenity, 1.5% water, and the remaining concepts had lower percentage. The visualization showed the most frequently concepts. The second phase was for that interpretation through the simple random selection of ekphrasis. These were chosen with a fraction of 10% to expose the effects of immersion. In the selection, an inference was made with the concepts tranquility, relaxation, and peace. Control group A, male, 25 years old. Part of the sounds in space creates a moment of relaxation. I feel immersed in space with a beach and waves crashing. A tranquility is generated and allows me to meditate. It is a moment of tranquility that allows me to get away from the daily noise of the city. Male, 18 years old. The sounds give me a feeling like someone very small in this immense world. I feel everything was very big and at the same time dangerous, but at the same time, sound relaxed me. There is a feeling of peace. Male, 24 years old. The various sounds give me emotions. First, a feeling of being in another space. A large place, this caused me an immersion. In addition, it caused me relaxation that leads me to meditate. Also, caused me a certain deep of space. Without restraints, group B, female, 19 years old. I feel like I am in an isolated place. It's quiet and safe, but at the same time, it's deep. You don't know where it is, and it causes anxiety. At times, I feel chaotic but immersive, like a place of peace. Male, 22 years old. I feel an infinite peace and at the same time tranquility. I feel separate from everything without any responsibility. I feel peace and calm. Female, 20 years old. The sounds give me peace. It's a place where I can reflect on personal uses. I feel free and serene. At the same time, I feel active, productive, peaceful, and stable. Conclusion. First, the sound reality on this experiment was limited by ekphrasis interpretation. This is one of the topics on reflection and consequences of the immersive perspective that tries to understand the cognitive process that supports it. The interpretations are decided in a problem with a deep roots that have been discussed in the philosophy of Kant and Husserl. According to Immanuel Kant, introspection allows us to be aware of our own representations, the action of the sound object, a weakness sensuous perceptions, which results in a concrete fantasy of the object in the imagination, from which the intellectual concept is derived. In other words, it is to possess our own representations. The psychologist Michael Meyer proposed that introspection informs us about thinking operations, the mind sizes for general theaters of things, their agreements of differences, the relations of cause and effect, the substance, and of course, the consciousness. Coming back to the point, the results made it possible to locate the auditory prospection of immersive environment and its perceptual and representative level. The location of each participant in the sound installation do not modify the perception despite the location in the place of listening. On the other hand, the introspection of the immersive sound produced a moment that was linked into consciousness and emotions. On the other hand, the concurrence of concepts, tranquility, relaxation, and peace configured immersive listening with independent variables. At the same time, they change the meaning due to its interference with the dependent variable. An important aspect in hearing was achieved with the creation of the time suspension effect. This resulted in the moment of enjoyment of listening and involved the mental construction of a mindful image with memories and emotion. Subsequently, the immersion effect emerged mediated by its cognitive implication. According to other researchers, the immersive experience is related to levels of autonomy, and variables are related to their own enjoyment. Ekphrasis allows the transmutation of the auditory perception of the sound object to the mental world and textile world too. Imagination and perception as elements which the inner world is construct evolve their domains. In this subjective paradise, there were desires, dreams, goals, and commitments. This means that the participants found themselves in the middle part of the immersive phenomenon, place of the cognitive interaction between the sound stimulus and its technological meditation. The study of thought expressed in the semantic contribution makes this clear. For the disaggregated units into perception, emotion, consciousness, knows, verbs, properties of matter, terms in their empirical reference symbolize universal notations and abstractions, but abstractions having their fundamentation in reality. Finally, ekphrasis as a social practice allowed the introspection to be transformed into a textual relation emanating from binaural sounds and the capacity of listening, empowering the imagination which gives meaning of the human being. Okay? I want to thank to the Korean Electro-Acoustic Music Society very much for the work it has done. Finito.
Thank you. Are there any questions?
I have a question.
Go ahead.
Alejandro?
Yes.
Congratulations. I really like this talking, this sort of experiment with I wanted to ask, was this conducted in Spanish? When you made this
Yeah, the original experiment was in Spanish.
Okay.
Yeah, in Mexico City.
Okay, right. And then just a follow-up question. I know that it's rooted in phenomenology, and so do you look at other post-phenomenologists like Wittgenstein or something where maybe they could also have a set where they draw something instead of maybe just having a word?
Yeah, the story of immersion and especially the perception starts with Aristotle, a very classical philosopher that wrote about human perception in the first level, and the other authors, Kant, Husserl, and with this experiment, I tried to analyze the phenomenon in other level and try to translate the sensation, the emotion, the dreams, the reflections in a rating exercise. that is called ekphrasis. Yes. Any more? Thank you. 고맙습니다.
고맙습니다.
You're presenting it in cohorts with Lulu.
Yeah, there she is. With that extremely clear title. Yes. Hopefully by the end of this you'll have a mild understanding of what I'm trying to get at. And I'm sure we'll get to watch her do all sorts of strange, squishy things as we do this. It'll be fun. I'm excited to be trying this because normally I do this at home and I'm like plugged into like 3 computers at once with this very like elaborate body setup, and now we're doing it nice and compact on this laptop. So I'm actually kind of excited to give this a shot. But yeah, so hi, I'm Matt. I'm a third year PhD at UC San Diego, out of Pueblo, and I'm going to show you a bit of what I've been doing kind of practice-wise, and I'm going to talk about why I do it, and that's sort of how we're going to go about this. I find that generally just sort of letting you experience a little bit of the sounds and visuals and stuff gives a better sense of sort of what I do and why I do it. So you're going to hear a bit of a set, do some visual audio stuff here with Lulu, after I make her thing go away. And then, I don't know, I kind of want you to just listen for what you think you're hearing vocally. That's a big thing. There's going to be a mixture of Vocaloid, like synthetic vocals, synthetic, I don't know why it's in quotations. There's a lot of like hypermodulated vocals, mixtures of things. And generally what I'm interested in is sort of perceptions of a single performer and how that sort of gets broken by a lot of digital media that we have nowadays. And that's sort of all the people that I work with and that I research with are all sort of in that field. So that's kind of what I'm getting at. Yeah, so I'm just gonna hop into some stuff. and we're gonna then move from there. And I hope you enjoy. I normally get a little active with the like full body movements and stuff. I'm gonna probably calm it down a little today. My neck's gonna want pain from a little nightlife research. So I'm gonna just take it a little easier. Great city. Yeah, with that, let's do it, and we'll see if this audio is working. And if it's like comes out blaring, feel free to turn it down if it's horrible, or you can mute this once I start the beatbox.
Sweet child.
This sort of whole deal started pretty much during the it was pretty much right when the pandemic kicked off. I got really into the idea of performing online. A lot of these Zoom shows started being offered, and I didn't really want to just stand on screen and do things. So I got really into the idea of this avatar, and it's just sort of kept going since then. I teach as Lulu if I can do Zoom, so I'll do classes where you don't see me. So performing like this, teaching like this is all sort of part of the game. And a lot of the music started coming from it as well. So you heard a lot of Vocaloid in there. There was you might be able to tell that some of it's more computerized sounding, but also the sheer amount of auto-tuning on my own voice might also kind of mesh in there. So it becomes kind of unclear who's who. And over time, I've found that I am less clear as to who's who. So that's sort of what I'm going to talk about a little bit. So let me switch into our little presentation mode. See if this works properly. Okay. Full screen. This might work. Beautiful. Okay. Nice. Okay. Yeah. So where do you even start with this? It's sort of I think a lot of times I talk about avatars, the idea of coming up with a character you're going to perform as. It starts to feel almost like if you're playing a video game, you have a character creation screen, and it kind of feels that simple. But I think the actual practice, when you go through creating this whole sort of persona and coming up with a physical appearance, coming up with the sound, it's a lot more intense than I think is generally given credit for. And I think especially in academia, it's not really studied that heavily. There's a lot of work on character creation and writing, but not as much in this sort of more digital sense that people are starting to get more of a hold on. I think this stuff is becoming a lot more prevalent even in the last couple of years. The other night I was in the hotel looking through channels, and I came across I from what I understand, it's the first one ever. It's like an Avatar idol show that's been airing on, I think on NBC, like, where basically all the contestants perform as these avatars in front of a live studio audience, which is funny because there's nothing on the stage, right? But then the judges judge it almost like American Idol or like an idol show. So this sort of obsession with adding more avatar content is definitely getting more prevalent, especially now that people have this term to use, like the metaverse, which was a sort of brilliant marketing job by Facebook to just decide that they now own this whole sphere that's been going since like 1990. You know, so that's great. But I think that really solidified too. I was like, okay, so clearly people are trying to uptake this, and it was just amazing to me to happen to come across that on TV the other night. But I've operated more in the sort of online world, a little bit more of a DIY aesthetic for it. So I'm going to talk to you a little bit about the performers that I work with, and I mean, they're like friends of mine usually. So I'm going to talk to you about my friends who do this. Yeah, let's get into sort of like what the core is. So what you heard was a lot of like vocal modulation, and you're also watching this body modulation. I come from like a critical studies, like gender studies background. My experience has always been that pitched up vocals and like highly modified vocals, the same way with a lot of highly modified digital forms, a lot of times have to do with folks exploring different parts of their body that they can't access organically. So this is a quote from Alice Gass, who's a really awesome DJ, and she said, "Back in my day, artists pitched up their vocals because of gender dysphoria." This is my experience with it at least, and it was the experience of most of my friends. Why people started doing this like pitched up aesthetic was because there was an interest in sort of feminizing your voice almost for a lot of like trans women and queer people. So nowadays it's become, I think, a little bit more entrenched in a lot of popular culture. You hear a lot of rap songs with, like, especially trap, that does a lot of pitch shifting with auto-tune, but I think a lot of this, if you trace the core, really goes to a long-running history of folks playing with gender via vocal performance, going back to even like Laurie Anderson with a vocoder. Like, I think we can go that far back with it, but to me, I focus in this sort of hyper-poppy world where people do this. What I find interesting is when I did some interviews a little while ago, this one was from Aaron Corbett. They said it was actually through that process that I eventually learned to love my voice. So there's this idea that you sort of step out of your own body, you check something out, you appreciate it, and then from that comparison, you actually start to like enjoy what was there originally, which I think is an interesting process that especially creative folks, I think, sometimes don't provide themselves that sort of like space to just like be unhappy with themselves, but then like actually, you know, appreciate themselves later. There's a lot of like self-critical aspects that I think are relieved by this sort of like disembodying process of creating this avatar, or creating this other voice for yourself. I can play a little of what Aaron's voice sounds like when it's processed. Very quiet. So like heavily processed. I learned a ton from Aaron. And that one's doing a bunch of like format shifting and auto-tuning and vocal processing there. So there's that process of stepping out, listening to it, coming back to it again. This is my very long slide that I won't do, but when I'm talking about, when I do longer classes with students about like lineages that I'm talking about, and when I'm tracing this like idea of like why pitch shift your voice, this is sort of my timeline I would take you on. We're not going to go that far, it would take a very long time, but just to give you a sense of like where I place my lineage, to me going from the voter to modern artists like Hunter Gax, Cartier, that's to me sort of where I see this. And Hatsune Miku being in the middle, because I just think like you can't talk about synthetic vocals without talking about like the largest synthetic vocalist in the history of the world. Still going really strong, like amazing to me. Hatsune Miku launched in like 2004, 2007. Still, like, you know, every single year there's like this massive fan base. They all come out to see the giant projection of this, you know, like a 16-year-old animated woman doing like these songs that have been out for, you know, nearly 2 decades. Pretty amazing stuff. And I connect all this with like my more, you know, academic-y gender studies background with Susan Stryker. And this is the quote that I like the most. "In birthing my rage has rebirthed me." It's from an essay called "My Words to Victor Frankenstein of the Village of Chamonix." It's basically like an extremely aggressive essay that I really enjoy that talks about, I don't know, the process of creating your self-image based around a sort of anger or a distaste. That's simplifying it, but that's sort of what I pull out of it. This is part of the poetry that shows up throughout the piece that I'm really into. But yeah, so while I'm talking some more, I'm going to play this. Basically, through all these journeys, the more I found with people is the further we could all push ourselves to sort of like get our vocals further away, to get our bodies further away, the more we got interested in like full-blown world creation. So a lot of folks, like myself, started making video games around these characters. This is like one of the initial builds of Lulu, with all these people chasing her. They do this like swarming effect that I'm really into, and then she kills all of them. Not really sure if I'm going to keep that in the end game. I don't think I want it to be that aggressive, but at the moment, that's what we're getting at. And also, a lot of us got into like rhythm games. A lot of me and my collaborators were like really into doing these like rhythm game styles, where we'd say like, what happens if we were to create, you know, you're forced to come up with like a battle, and you're like, okay, well, who is if my fate character is fighting somebody, who are they fighting? For some reason, it was this dog coming out of like a cell phone. I think that's like some sort of subconscious thing that I have a problem with the internet, but I always enjoy that these sort of things can pull stuff out of you without you really knowing it. There's something kind of weird subconscious that goes on there with this process. And then teaching as it as well. This is my this is a Unity environment that I built for you can do like text-based input and like trigger stuff in the world to happen. So it just like keeps students from getting bored. That's pretty much what I use it for. And it's been fun. So here is me presenting a different presentation. And as you can see, I've locked in the font. So going back to this sort of this image, we have blue tentacles, Saint Tate, Mac Shaper. I don't want to talk about Saint Tate as much. That's sort of a performance entity that I've used for years for like live performances, not as an avatar. But what I found really interesting about the process is it sort of like it just like more and more disembodied me over time. And there's some sort of like engaged practice that feels very different than most of the research I've done in the past, where it's been very simply like, I'm going to do this thing, I'm going to do this interview, I'm going to write about it, I'm going to keep myself out of it, you know. And I think the more that I've engaged in really having to push myself to ask like serious questions about my own identity, the more I've taken my interlocutors like way more seriously and learned a lot more. And so what's been interesting over time is, you know, I make this character, and then I kind of like slowly started pushing myself more towards her, like in organic form. I like got really interested in all these sort of like aesthetics she had. If you saw me in the US, the lower half of my shirt probably wouldn't be here. You know, I'm always hopped up on estrogen. There's just like a lot of big changes that sort of happen based on using this digital form to just kind of explore things. The other one I got really into was, since I was playing with all this vocal modulation, what it means to do like organic vocal modulation. So I got really into working with like speech pathologists about like vocal feminization. So like when you start moving your voice up here and you start training to like hold your voice in a different register, that's something that people work on a lot, especially with trans healthcare. You'll learn to sort of keep your voice at an upper register, pull your kind of like larynx tighter. And it's been interesting because you start to realize that all the terms you were using, like pitch, are actually kind of like incorrect most of the time. So like in these examples, right, where I'm going sort of like, it feels like I'm going up and down, the pitch is actually staying pretty much exactly the same if you're using like a pitch, like an actual pitch monitor, but the format of my voice is changing a lot. And that helped me way better understand what was going on digitally, where everyone's doing all this format shifting, because you're like, oh, it's quite literally the digital version of tightening my throat against it, or like widening out my throat to like talk at a gas station. You know, so it's like, it's been cool, because I don't think otherwise I would have even considered pursuing some of these routes had I not sort of like seen this body and voice and thought it'd be really cool to do that with me, and maybe not known that consciously, but over time sort of gotten more and more in that route. So like, who cares? This is one of the bigger questions I would pose out. I think beyond like a hyper-personal level, I mean, obviously I come from a very experiential-based sort of research, like very much like we're going to talk to 10 people, we're going to see how they feel about something, and that's going to be the research. But if you want to look at it like larger levels, which some people like to do, I do think that this sort of stuff just points to much bigger shifts in how we see artists and how we see individuals going forward. I think the idea of like a sole artist or a sole individual on the internet is kind of not a valid framework anymore. It's not really like very productive to think of people in like one body. I think a lot of times you have to consider all these different forms people take inside of the internet and outside of the internet in real life. I also think when you look at artists, there's more and more of these sort of fully digital artists that are starting to kind of come into the music industry. Some of the biggest ones here who Korea would be like KPA, from like the League of Legends game, like they just like had this like massive record deal that they've set up. And a ton of these artists are now starting to pop up, and VTubers that are just starting working on the internet. And it's becoming kind of unclear how you're supposed to judge like who the person is. It's kind of unclear what their legal rights are. If it's not like a person, it's more of like an entity. So there's a lot of questions I think this stuff brings up about what kind of protections people have for their likeness, and how we're supposed to really judge artists that we're used to seeing as people that sort of say things, do things, and now there's actually this much more complicated aesthetic of like 6 different people can be operating this artist. Who said what? How do we judge that, you know? But there's also some real beauty in that. It's really amazing to have like a collectivism in the way that you approach creating art. You know, you can have a collective artist that you and your friends are all running at once, which is something that's really powerful, I think. And it also means that, you know, Lulu here, who is just really fascinated with the ceiling. Lulu could live on as long as she needs to, even if I decided to stop working on it. I could just hand Lulu to somebody, she'd keep going. And that to me reflects a lot of interesting possibilities for what we're going to see moving forward, like someone like Hatsune Miku, who has been perpetually 16. And will continue to be perpetually 16, probably forever. You know, and I don't know, I think I don't think that we're quite equipped to process that, at least in academia, and certainly not legally either. But that is a big topic for another day, and if I ever finish my dissertation, there it will be. But yeah, otherwise I just want to say, if you want to try this stuff, I think one of the coolest things is to teach people, like, especially my students, teach them if they want to try this and explore and do their thing, like how to do it. There's free ways and there's not free ways and there's very not free ways. The free ways that you can do, M-Auto Pitch is really great for like working with pitch and formant on your vocals. When I do this presentation online, I usually put a bunch of effects on my vocals. I've actually usually never do this in front of people with my body here. And it's actually kind of interesting. And VR Mode Studio is a way to spin up avatars like really fast. It's free. And then I build things in Unity generally, which is free, but obviously takes a little bit of work to get it done. But you can actually run a kind of like janky version with OBS, Open Broadcast Systems. And if you're on Mac, you can use this thing called FreeTeam. And basically, if you just work with kind of passing things through with enough ability, you can get some pretty solid tracking going. Or if you want to go the other way, I mean, Alter Ego is like a free way of doing Vocaloid, which is basically text-to-speech for vocals. And then there's obviously Vocaloid, the piece of software, which is the really expensive one, but it's like totally amazing to work with if you ever get a chance. The interface is terrible, but like it'll blow your mind when you like first write a vocal line in somebody else's voice. It's a very strange thing. And politics of that, I would point you to iTime if you're ever curious about what it means to, write somebody else's voice. iTime's got some really interesting work on that. Yeah, and that's how I would probably go about it if I wanted to give it a shot. But if you ever are trying to do this and you run into a bunch of questions, that's my information. That's my Instagram handle. My mother really likes the name, and that's what I do. Yeah, that's kind of what I'm up to. And I figure with the rest of the time, if people have any questions or want to talk about process, we can do that. But thanks for listening to my stuff, and Lulu, thanks to you, and thanks for having us. It's been like absolutely awesome to come here.
Any questions? Comments?
Can you show me the controller when you're during the performance?
Yeah, like during the live part. Yes. Okay, so I've done a lot of different versions of this over time. I'll show it to you. Try to be sure. Sometimes I've done like the visuals are sort of pre-done and they'll fire off randomly, and then I'll live DJ. And then other times I'll do it the other way, where like I'll get the DJ set up, and then I'll do all the visuals live. I tend to prefer to do the visuals live and get my DJ set pre-done for like shorter style things. Obviously, if you're gonna play for like an hour, you don't want to do that all in advance. If you're gonna play for 9 minutes, might as well just do it in advance and then do all the cool visuals and try and keep her from breaking. Let me see if I can show you if I get rid of OBS. Let's see, how do you get rid of OBS? Let me see if I can full screen this thing. Oh yeah, we got it. I've been using for the visual side, I run it through MatMapper, which is like a projection mapping software. I come from like a lighting and projection background. That was like my pre-academic trade. Went to like a kind of vocational high school for that. Good times. So I got really accustomed to using this thing. The interface, you can see it's a little weird right now, but basically what's happening here is I can get a bunch of these sort of queued up things. And if I go here, you can see, it's a good shot. If I move through these different shots here, I can do like videos and overlays, and a lot of them are triggered up to like audio reactive stuff. So I use loopback to basically make a signal chain inside the computer that loops the audio, throw the audio into ear, throw the audio out to ear, throw the audio also out of Ableton, and then it can basically just hear the input and react, and then I can live move through things and also adjust the movement if I want to. But I mainly do that, and if I was gonna live DJ, I would use like Rekordbox, but usually I just have Ableton, slap a nice timeline business in there, hit play, because it's a lot to do at once, especially without two computers. But yeah, I think, does that generally get there?
Were you controlling the sound with your keyboard strokes?
Partially. Not like fully live mixing at this time, but I could do like some like general effects work and stuff like that, or like make some like skips and things. I've done the full live thing on, and it feels fine, but a lot of times I feel like I'm all about like what is the experience of the person, and what I've generally found is like people don't notice if I do the audio live, but they definitely notice if I don't do the visuals live. That's like usually what I've found is like people just like don't see it like land as hard, and so I just kind of like chose to focus on the visuals. But ideally, I'd have like some person hiding behind like a box, you know, like doing some like Lulu piloting or visuals or something, and then I could do something else. But you know, when you're doing it yourself, obviously, she can't do it herself. So that's just me. But yeah.
If you're babysitting the computer, you can't think about performing.
Yeah, that's always my issue, and that's when I perform live. It's the same deal. I always try and like get as much pre-done so I can just like do goofy things on stage, you know, because it just like that's what reads with people generally. But yeah, but sometimes also it changes. Like if I can do a setup like a full motion capture suit that I started working with recently. It's a little more challenging. Not like a travel-friendly device, but if I do that, it gives me a little more flexibility because then she really just does whatever I'm doing. But otherwise, one of the constraints is if I'm using face tracking from the laptop, right? Like I need to be like in front of it, or else she won't know what's happening. Sometimes I can do hand motions too, like with a leap motion. You know, like $50 on eBay. Slap that thing in, and like it'll get the hands tracking. But it only works on PC. So since I'm running the Mac version right now, no hands. But alas, they usually just kind of go like this, like as soon as you go to the keyboard. So like honestly, I'm kind of okay with it. But yeah.
I see. So you can control her 10 tentacles with the 10 fingers.
That's okay. That's what I'm trying to get at. I want to do like a full puppeteering rig with them because I think that would be like the most interesting thing. In the game design, the tentacles all have these like they all kind of have their own little brains, like programmatically. So like when they see an object or like something that's tagged as like an enemy or whatever, they'll like snap to it and follow it. It would be really cool though if I could like pilot that with some fingers. I have some like finger tracking gloves. I thought that'd be interesting. At least it'd be hard to do, I guess, with stuff, but it would be really sick if she had a bunch of like virtual consoles around her and she was like slapping it. I think that would be sick, but that's beyond my reaches at the moment. Yeah.
Like regarding the comment you made, I think the first thing we noticed was the first thing you noticed is that when you're in front of us, she's looking at me.
Yes.
Because it became very clear quickly that you're used to doing this at the screen, not
like jammed down into it. Yeah. And it's always such a trip to try and do it because her head just wants to snap all over the place. This is one of the things that the motion capture, like full body capture fixes, right? Is because it's all based on like it's all like gyroscopes and stuff, right? So you got like a little strap around your head. But yeah, normally being like face down on it like this does kind of change the tracking system. I also personally think I'm using 3Teen in here. If you can use a Windows version, there's a program called VC Face that's free that can pass like OSC into Unity and can also do tracking. It's way better tracking in my opinion. But I don't make it Mac. I don't want to carry 2 laptops today. So we're on Mac.
I have a question.
Yeah.
I know we're in the same program. I can just ask you anytime. But I figured we'd. You were saying that there needs to be more study with as far as character creation, not just as a written form. Would you say that this sort of new avatar idol, that maybe the parameters for the judges, the judgment of these avatars could be ported into a sort of like a way to codify character creation, but in academia, since there is clearly a mapping of ways to sort of judge how things are done and why judging against each other. Have you thought about maybe that could actually be brought in as a sort of theory of avatar creation?
Interesting. So you mean kind of like packaging sort of like a theory framework specifically around the creation aspect? Is that sort of how you're talking about it?
Yeah, or if character creation was taught based on the parameters that are being used for judging the contests.
Oh, interesting. Okay. Like you talk about like in the show, for example.
Yeah, not just specifically, because there's a lack of sort of theoretical body of work. That is sort of like parameters to think of when.
No, I think I kind of get what you're talking about. Yeah, I don't know. It's tough. I think the main issue with trying to like figure out like how to like classify anything with avatars is that there's so many layers of like, I don't know. I think what's weird is like, for example, like when we're in the US and we're talking about like identity or like appearance or physicality, whatever, there's a really different way of talking about it than the rest of the planet half the time. Like, or like any, like we have, I think in the US, like a very specific way of going about things that is leads to a lot of really interesting conversations and also leads to a lot of like ultra alienating ways of discussing things. That's sort of how I've always generally felt about like when we describe things like the body of an avatar or the identity of an avatar. So what always becomes tough for me is like trying to come up with a way to come up with like a framework for describing, I don't know, like race, gender, sexuality of an avatar, but also trying to come up with one that still like reads internationally in a way that's not like jamming this sort of like very like American feminist sort of like thing that I've been taught to do, like down on people. I think that's sort of something that I struggle with. So like when I talk with Louis, for example, like all I want to talk about is like transness and avatars and how like you know like the or like race and avatars and like the politics of like piloting one skin toned avatar versus another depending on who you are. But then it starts to come into conflict with like the actual market so much, you know? I don't know if I'm being clear enough about it, but I think I've been really struggling to do it the more that I engage with like especially like Japanese and Korean VTubers. The more I engage with those folks, the more I'm like, okay, like this is actually like a really complicated way of discussing like how these people identify, you know, as opposed to just talking to like an American gender studies academic who can immediately just be like, yeah, this is like how I fit into all these like spectrums of things, you know, and maybe those don't actually make any sense once we take them abroad. I don't know if that makes any sense, but I don't really know otherwise. I wish I had a better judgment for it. But in the singing competition, they just do it because they're like, I really like this superpower that you slapped on your avatar. It's gnarly, you know, and it's like they like shoot fireworks out of their hands or something, and then they sing really well. So like we loved your voice. The weird thing about the show that I thought was interesting is that they pitch up the people's voices when they're talking to them in the interviews, so that you like don't know who's who. But like they do gender everybody. So I'm not really sure what exactly the pitch up method is supposed to be achieving, but it's kind of interesting either way. Yeah, I don't know if that answers it, but that's sort of like where my brain's been at. Like it's been definitely like struggle to sort of like lock something in.
And just to follow up regarding the pitch up, because you show us a timeline of the sort of, I know not a great word, but genealogy of pitch shifting and vocal or performance shifting. And do you also have a similar one for the sort of the like telematics or holographics that have to do with like the actual bodies?
I do. I don't know if I have time to like do it, but like there is one hidden in here somewhere that maybe I can slap on for like 2 seconds. When I do like a longer lecture, I'll do like 2 timelines sort of next to each other. Because with the vocals, usually I remember one time we were talking to Nina Itzheim on a Zoom call, and we were talking about how like humans trying to sound like robots and robots trying to sound like humans, like intersecting, and that being like a timeline point we're at. You might remember that. And that's sort of how I've been trying to trace also like the bodies and the voices. Is there's like these 2 timelines of things intersecting right around now, in my opinion, where you start to not really know what's robot and what's human. But in terms of the layout, this is, I can just like drag this over really quick. Yeah, okay. This is generally like how I would go about it. MUDs are like the first multiplayer RPG basically. It's all text-based, that's what MUDs are. Crazy Frog's penis, that's an important topic that I would get into, but we don't have time for that. But really interesting social issue where they got rid of his genitalia, which I think is fascinating. Yeah, content videos here, and like Lil Michaela to me is a really important like VTuber. But I think if I had to pick like the current top craziest thing that I know of, it's probably Code Miko, the like streamer who just has this like hyper-real avatar. Everyone's triggering stuff in the background. Like her body changes based on people's inputs into the chat. I mean, it's just like off the walls, and it's like you just don't know what's going on. It's really hard to like try and parse through all this complicated stuff. At the end of the day, in her interviews, as much as I want to get all theoretical, she's just like, yeah, I'm just messing around. I make a lot of money. And you're like, okay. So I guess that's as far as you like push this one. But I do think she's important because she's like she was a total solo dev, and she just kind of spun up this like unbelievable avatar setup that I don't think anyone has topped, even with like a lot of money behind them. So I do not know how she pulled it off, but it is really crazy if you ever look her up. You also might hate it. It's a very polarizing internet figure. But yeah. Yeah, I don't know.
Cool.
It's probably
Okay, yeah, I think our time is up. It's time for a break. If there's any other questions, obviously you can talk during the break. So, okay, we have about 25 minutes for the break.
Get out of here, sorry.
So about 25 minutes for the break, and we'll reconvene at about 14:20.
That's actually it's another named Lil Michaela, and she
T-1 minute. I'll go ahead and introduce you to maximize your time. Our next presenter is going to be Gerrit Eckel, who's from Peabody Conservatory, well, not obviously from there, but is coming from there right now. His paper Easy DSP, as you can see, from production to programming, is the subject he's going to be discussing. So it's all yours.
Yeah. Thank you guys for having me. My name is Gerrit Eckel. As you said, I'm from the Peabody Conservatory. I'm going to be talking today about a plugin that I've designed called Easy DSP, which is short for Easy Digital Signal Processing. Quick introduction just to me. So yeah, I got my master's in computer music. I graduated this spring. I currently work as a software developer at a company called Riffit, where we're developing a real-time text-to-song platform. It's for like kids with learning disabilities. So you can put like a page of textbook into the app and it'll like convert it into a song and sing it back to you. And yeah, in my free time I like recording, writing rock music, which is kind of relevant here because what Easy DSP is actually about is kind of bringing advanced audio programming techniques directly into the DAW. So I mostly work like in a standard digital audio workstation, for me, Logic. And obviously the options for doing like advanced signal processing in a DAW are kind of limited compared to something like C-Sound or Max MSP. I don't want to get too far ahead of myself, but so yeah, what is Easy DSP? It's an audio plugin developed for creating custom digital audio effects from directly within a digital audio workstation. It's powered by the Soul language, which we'll talk about here in a minute, and it allows users to create and modify digital signal processes in real time. So yeah, I had a couple goals for this project when I took it on, I think sometime last year this started. Yeah, one of the biggest ones is kind of bridging the gap between music technology, computer science, and electrical engineering. Obviously I took a lot of computer music classes during my grad degree, but I also took a electrical engineering class in digital signal processing. And one of the things I noticed is that a lot of the kids there, they had like the theoretical knowledge, but they didn't have the ear training to like understand if an effect was actually like pleasant or was like good. So I'm trying to kind of foster collaboration between musicians and engineers with this project. The second goal is making advanced music production more accessible. Kind of like I said, a lot of people maybe might not have access or the understanding of something like Max MSP or Super Collider, but maybe they have access to a DAW. And so if you have access to a DAW, Easy DSP works in pretty much any of them. And then lastly, yeah, this is kind of designed as like a teaching tool for like teaching digital signal processing through a musical lens, just because I think it's more fun that way than learning through financial signals or even imaging. So yeah, this is just kind of a brief overview of what Easy DSP looks like. Obviously we have like our GUI interface up there at the top. And then we have our DSP editor there in the middle. That's where we actually do our DSP processing. And then we have a bunch of buttons at the bottom that we'll go over in the next couple slides. Yeah, so a technical overview. Nothing crazy important here, but we see Easy DSP itself is made with the Juice library, so it's a standard C++ plugin. But then the underlying DSP code is written with the Soul language. So Easy DSP obviously works like a standard plugin, and then it passes the audio into Soul, does all the processing there, and then sends it back out. Officially supported DAWs, I know it works well in Logic and Reaper. It should work in other DAWs, but this is kind of experimental technology. I mean, I don't think DAWs aren't supposed to handle something like this, passing audio into a different language. So these are the only two I can guarantee work well. It's available as a VST3 and an AU plugin, and I have versions for Intel and the newer Apple Silicon chips if you're on Mac, and then Windows 10 if you're a Windows person. So yeah, there's a little bit of background information we need to cover before we get into actually using Easy DSP. I want to talk about kind of how it was created. And the big concept here is the difference between compiled and interpreted languages. So almost all plugins nowadays are written in C++, which is a compiled language. And the great thing about this is that when you make the plugin, you click run or build in your integrated development environment, and it takes your code and it converts it into like a series of ones and zeros. We call that like machine code. And so your computer can inherently read that code on its own, which means it can run really fast because it doesn't need to interpret anything. Your computer can run it without any middleman. So this is great for audio programming because obviously we have to program thousands of samples per second. Whereas something like an interpreted language, you probably would think of like JavaScript. What actually happens there is the code gets delivered to the user's computer, and then the user's computer has to have a JavaScript interpreter that kind of runs the code on the user's machine. So if you have any sort of web browser on your computer, web browsers obviously come with a JavaScript interpreter that runs JavaScript on your machine, not the developer's machine. So the nice part about this is it's more flexible, right? Because we can change the code up until runtime, whereas with C++, we can only change the code when we build it initially. Which brings us to the Soul language, because Soul is an interpreted language. We see the Soul stands for sound language. And the interesting thing about Soul is there's two components to it. So on the left-hand side, we have the Soul language, and that's like an embedded programming language for writing DSP code. We see at the bottom there it's fast and memory safe, which is important for this because this is meant as a learning tool, so obviously we want to make sure we're not having memory crashes, especially if we're working on like a big DAW project. You don't want to lose your data. But Soul is also a runtime environment. So remember I talked about the JavaScript interpreter, how that interprets the JavaScript code. Basically, when you use a Soul application, you have to have the Soul runtime environment on your computer. And what that does is it takes the Soul code and then it optimizes it for whatever processing power you have on your computer. So if you run a Soul program on a simple laptop, that's fine. It will just run it on your built-in CPU. But if you're hooked up to like some really advanced like DSP or GPU processors, Soul can actually take the code and it can pass it out to those processors. So basically, you can optimize the code at runtime, which allows us to do faster signal processing when compared to something like JavaScript. So yeah, this is a flow chart of EasyDSP. Let me try to explain this. So the outer two layers are C++, right? So that's like a standard audio plugin. The outermost layer is the source code that I wrote, and that basically communicates between the DAW and the inner Soul code. So it handles things like input and output channels, automation, and all this stuff. Inside that, we have an abstraction layer that basically takes a Soul patch and it converts it into a standard audio processor, which is like a juice object. And then within there, we get into the Soul code, where Soul patch is the format that comes with the Soul language. And then within that, we have the user inputted DSP code. So when you click run in EasyDSP, it dynamically generates your DSP code and then inserts it into the Soul patch for you. So yeah, now we can talk about how EasyDSP works, and then I'll show you guys a couple examples at the end. So yeah, there's two main components. There's the component creator window and the DSP editor. The component creator window is where we're going to create like our visual components and also like audio buffers and stuff like that. So we do this visually. It's not typed in the DSP editor. And these are global variables. So if we want to create a slider on the screen or a button that we can interact with, we can go through and fill out this form and then click create. If we go to the next slide, we see here's like if you want to create a slider, you go through this and you choose a minimum value, maximum value, initial value, step value, and you give it a name that allows you to access it from the DSP code. This will be easier to understand once I show an example. I think it's kind of harder to explain. But yeah, the DSP editor, so this is where you're actually writing Soul code. It exists within a per sample loop, which is really important. I think one of the great things about this is that it kind of abstracts out some of the more complicated aspects of digital signal processing, and it kind of allows you to focus on the core concepts because you're not dealing with audio buffers for the most part. You're working with just one sample at a time. So you get a sample, you process it in some way, you shoot it out. And if you need to process buffers, like if you're doing like frequency-based processing, there is a way to do that, but it's not like you don't have to worry about that if you're just doing like time-based processing. Yeah, then audio in and audio out are the two built-in variable names that we use to get the input signal and then pass it out to the output signal. So we see in this example here, we're just, we have a slider called gain in all caps, and we're taking that the value of that slider and we're converting it from a dB value into a multiplication factor, and then we're just multiplying the input audio by that, and we're sending it out the output. Yeah, so a couple miscellaneous features that took a while to implement. The biggest one is automation, because since the audio processing, all that exists within the soul code, your DAW actually can't see it inherently. So what I had to do was add my own automatable parameters, and then track the soul parameters and try to match it up with those, which is really tricky because one of the limitations that plugins have is that you can't change the number of automatable parameters after you put the plugin on the track. So obviously I don't know how many sliders or whatever you're going to create at runtime, right, since we're editing the plugin in real time. So EasyDSP is actually limited to 5 sliders. So I make 5 automatable parameters right at the beginning, and then I created a custom parameter class that can kind of customize itself to fit your slider. So it'll change its name to whatever slider you created. But it does, the automation values do exist in a range of -1 to 1 because you also can't change the minimum and maximum value of a parameter in a DAW after you initialize. I also have to do stuff regarding DAW project information, so I pass in stuff like BPM, sample rate, time signature into Soul, and so those are like built-in, like not constants, but built-in global variables in EasyDSP. So you can use stuff like a numerator for the numerator of your time signature, or like samples per beat if you need information like that. And then there's also some like input-output configuration stuff. So like if you're on a mono track and you want to make it stereo, or you want to mix down to mono, EasyDSP can do that automatically without like worrying about. You don't have to worry about stereo channels. You're just kind of working in mono, and then yeah, that's that. Yeah, so that's actually most of what I wanted to talk about. I wanted to do a live demo now, and code one of these in front of you guys, so you can kind of get a feel for how it works, and then maybe we can look over 1 or 2 more examples after that if we have time, and then I'll talk about some things I want to improve and kind of how I see this hopefully being used. But let's first do a live coding of just a really simple distortion plugin. So we're going to use a sigmoid function and apply that to the incoming signal to round off the edges, kind of, if you think about a sigmoid function. So this is the equation we're going to be using, which looks more complex than it is actually. We see that in 2 spots here we have x over absolute value of x, and same here if you factor out a negative x. And all that's really doing is giving you either a -1 or a 1, right? It's just like a polarity thing. So if we substitute that out, we basically get fx equals polarity times 1 minus e to the negative polarity times x. And then if we put that in coding terms, obviously we wouldn't actually use that equation, we would just do it like this. We would say if x greater than or equal to 0, use this equation, otherwise, we use the other equation. So let's, actually go to slideshow there. Let's load up EasyDSP and take a look at how that would work. So I just have like a really short guitar audio example here. It sounds like this. Is that the right?
No. You are output connected.
Yeah, I think I outputted to the HDMI instead of I want built-in output. I have the headphone jack plugged in. Let's see. There we go. Cool. Yeah, so there's that. And if we go into our audio effects here, go into audio units, Squatch Sounds is the arbitrary name of my plugin company I came up with. And yeah, so let's load up EasyDSP, and we see we have the same example that we saw before with a simple gain knob here. So if we click play here, we can affect the gain obviously, and we see if we go click on the automation tab here, go to ECDSP, we see we have one automatable parameter here called gain.
Are we supposed to be seeing the lighting on the screen?
Oh, you absolutely are. Okay, so I switched desktops here, but it did not go over there.
Mirroring.
Yeah, I can probably just bring it over to, I can just go on this one. Shouldn't be a big deal. Oh, I guess it is a big deal. Yeah, well, I mean, no. I'm using multiple desktops. Maybe that's not the right move.
Display is mirroring.
Display. Alright, let me go in options here. Arrangement, mirror displays. Okay, that's promising. And if I go to Pro, there we go. Okay. Yeah, so we see we have the same example here that we saw in the presentation. And if we click on the automation tab here, we see that we now have one automatable parameter called gain. So yeah, let's work on implementing that distortion effect we have. So the first thing we want to do is we're going to need an if statement. We're just going to say if audio in greater than equal to 0, then we'll do something, else we will do something else. So if I remember correctly, the formula for that, and actually let's make another variable here, and we'll go float dist sig, and then if audio in greater than equal to 0, we can do dist sig equal to, and let me go back over here just to remember, 1 minus e to the negative x, minus, e I think is 2.718 to the negative audio in signal. Otherwise, we want dist signal to be -1 plus pow 718 to the audio in. Another tip is we usually want to put f's after our floating point variables. Just simplifies things. It'll take a long time to explain, but yeah, that's the suggested way of doing that. All right, and then we want to output, instead of audio in, we want to output our distorted signal times the master gain. And if I click run, we'll see if we get any errors. Okay, we didn't. So let's listen to this, and we're probably not going to hear much of a difference, actually. So if you turn it up a little bit, you might hear a slight bit of distortion, but not a ton, and that's because our input signal is actually not very hot, right? And with the sigmoid function, we need to get a really hot signal before we start to hear that distortion. So let's add a second slider that gives us some drive, right? So instead of, right now our slider is affecting the final gain, but we want to apply some gain before to get that signal hotter going into the distortion algorithm. So if we go into the component creator here, we see we have our one slider in here. Let's add another slider. And we'll give it a minimum value of -10, max value of 50, 0 initial value, step of 1, and we'll call this drive. And we see now that we have a second slider here called drive. And we'll copy this line here to get the drive slider in as a multiplication factor instead of a dB factor. So we'll get the drive value, put it through there to get a drive gain signal. And then let's make let drive sig equal audio in times drive gain. So we'll make a new sample here that applies the drive. And then instead of checking, I guess we can leave that as audio in, but basically instead of using audio in here, we now want to use that driven signal. Drive sig. And let's click run. Okay, so now if we click play, and we increase the drive, we're going to start to hear some, yeah, there we go. Start to hear some distortion. So one final step here is that I usually like, and some people do this differently, but for me, the drive gain shouldn't actually be driving the actual gain. It should only be driving like the distortion algorithm. So because we multiply by the drive gain signal here, I actually like to divide by the drive signal, drive gain at the end. And that basically cancels each other out, so it's only applying more gain into the distortion unit and not boosting our actual level. So now if we click play, we start to get distortion. It's actually quieter because we're driving down the signal really hard, but I guess we can always apply makeup gain then. So yeah, that's kind of a really simple overview of how EasyDSP works for creating effects. Really quickly, let's see, 10 minutes around?
Yes.
Okay, so I'll go through really quickly. So the other two, right now it comes with 3 presets. So we also have easy delay. And we see that has 3 sliders. We have a gain slider and then a feedback and delay slider. If we look at the code here, let's go into the component creator. We see we have the 3 sliders and then we have a buffer called delay buffer. And so I'm not going to go through this code line by line. It's all on the website. I'll give you a link at the end if you're interested. But basically we're taking signals in, we're storing them in the delay buffer, basically a delay line, and then we're outputting it later on. If we could play there. We can boost up the delay and the feedback. And we start to get a delay effect. Obviously, one of the weaknesses about this is right now the delay time is set between 0 and 1. I should probably go back and change that so that it's like a millisecond based system, based on the sample rate. I think when I made this, the sample rate variable wasn't working, so I just made it between 0 and 1. Then we also have a filter. This one's a little more complex. We see we're using an inner loop here, and that's because we don't want to reinitialize these coefficient variables every time, so we're doing some kind of almost hacks to basically only have those initialized once, but we can click play here, and we see right now it's a low pass filter, or we can click here and make it a high pass filter. So yeah, these are nothing groundbreaking, obviously, but they're just kind of like starting points for anyone who would be using this and would want to like experiment with making audio effects. So I'm going to go back over to my presentation now. Yeah, future improvements. There's a bunch of things I wanna update here. The first is error handling. We actually didn't see. I assumed we were gonna run into an error at some point because I usually at least make like one mistake. But right now the error handling is a little weak in the sense that when you have an error, it doesn't tell you what line the error occurs on, and that has to do with the fact that the line it is in EasyDSP isn't the same line it is in the final code base. So I have to do some math there to figure out where it is in the user's DSP text editor. I haven't gotten around to doing that yet. Code completion is another big one. I don't know if you noticed this, but when you use like a variable or you access one of your components, it'll highlight it, like it'll be blue. But I'd love to have code completion, so if you use any of the souls built in functions, like when I use POW for power, it would be nice if that like autofilled or gave you a list of all the available functions there. Another feature, this one I think would be really cool, is I want to make it so you can literally just take your EasyDSP patch, click a button, and it would export it out to a full-blown VST or AU that's like completely in C++. The guy that made Juice also made Soul. So he wrote some functions, basic functions for converting Soul code into Juice code. So that definitely is possible. It's just something that I think will take a little bit and kind of some serious automation there. Windows is a little buggy at the moment. If you download the Windows version, it's actually in the debug. Like when you program, you can release things as debug or release, and normally you develop in debug mode and then release the release version. But the Windows version that's released is actually the debug mode right now because the release version just crashes for some unexplained reason. And then I want to make an EasyDSP namespace that would kind of bring this closer to like a MATLAB type thing where you'd be able to do some like research kind of functions for like different types of transforms. I think Soul has one for a regular FFT transform, but there's like Z transforms and all sorts of other interesting things that I think would be helpful to make available to users. Yeah, and then the last thing is I want to create like an online forum for people to like share easy DSP effects. Eventually I want to make like an easy DSP file format, so you can just send it to someone with easy DSP and they can just load it up in theirs. Right now you can just do that by exporting your presets. You can save a preset and then you can just export it as like a VST preset or AU preset. And that's kind of the way I imagine it working. Like if you were going to use this in the classroom, would be like the teacher would upload a preset to like Blackboard and say like, hey, here's a starting point for a distortion effect. Try to make this sound, warmer or whatever, and then all the kids would like submit a VST preset, back or whatever. Yeah. So one second, I'll really quickly just. Where's my mouse? There we go. I have a basic website for the setup with no regard for digital or like web design, and you can't see it again. Oh, there we go. But yeah, so it has all these, the examples I just showed, it kind of explains them in further detail, and it goes by line and kind of tells you what every line's doing. There's kind of a full documentation that talks about like data types, casting, all the built-in Soul functions you have available, global variables. And then there's download links here. If you're on Mac, I would suggest just using one of these universal builds. If you know what all your architecture is, you can go for like a Silicon or an Intel build. But I think these are a little bigger, but it's just safer to use one of the universal builds. And then for Windows, you only have one option. Yeah, before I end, I just want to say thank you to the Korean Electro-Acoustic Music Society for having me, and the Peabody Conservatory for helping me get here. I agreed to come here before I looked at flight prices, and then I had to go begging to the alma mater for a little money to get here. So yeah, I'm really happy to be here, and yeah, thank you guys so much.
Are there any questions? I want to start. How about zipper noise? I guess you have some kind of like line or lag function when you move a slider. So when you move a slider, there was no zipper noise, or maybe you just were moving it.
Yeah.
So like, is there some kind of interpolation?
Smoothing. Yeah. That's
It sounded like there was some kind of.
Yeah, thankfully that's built into Soul.
Okay.
So when you make a slider in there, so I didn't have to worry about that actually. It's been nice.
Now, a small question.
Yeah.
In case of filter, which method did you use to decide the coefficients?
That was the Robert Bristow Johnson bicloud filter. I think there's a couple other ones like built into Soul that you can use.
Built in Soul.
So yeah, like the Soul implement, if the Soul code base had that built in actually.
And they're probably also based on the Bristow Johnson Audio EQ cookbook code.
Yep. Yeah.
Because I think
everyone
uses that.
Yeah. Yeah, it's a testament to like how long that has survived. So we see down here, in the filters, in the Soul filters library, we have RBJ underscore EQ, and that we're just calling the update function, which updates the coefficients here, and then we normalize them, and then down here we process do like a cascading process there.
Okay, got it.
Like I guess there's all sorts of memory buffers, kind of storage and stuff. Like I mean, like you could like, for example, you could do a physical modeling synthesis thing where you had matrices of pointers to arrays, and I mean like any kind of coding thing, you could sort of like reserve the memory ahead of time, and it would be there.
Kind of. So this is limited to effects. You can't add it as like a synthesizer.
Okay.
For now.
Okay, but I was just thinking in terms of DSP coding. Like,
Yeah.
let's say you're going to use some kind of physical model of a gong as a resonator, and you're calculating it on a 2D point kind of basis of mode shapes and stuff like this, and want to have like buffers full of current state. Calculated.
Yeah, it should totally be possible. And if you create a buffer, so like you could create a buffer right here if you wanted to, right? You could like my array equals whatever and like that.
Okay.
But if you create it through the component creator, that it becomes like a global variable, and I put in some protections in there. So like if you try to access an index that's like beyond the array, it like loops back around to the beginning. It does some stuff like that just to kind of like make it as simple as possible and make it as like crash proof as possible.
Cool. If there's no other questions, let's move on.
Thank you guys.
What comes next one? Thank you.
Okay, my name is Hildebrand. I am from Madrid, and I try to explain the process composition of one of my pieces, broken game for percussion and light electronic. The first thing I like to explain is the computer-aided composition can be seen as process for the composition itself, for digital signal processing, and even for the final mixing and post-production of the piece. Also, I like to say that music and mathematics and partly from the clip time to the mix to the elegance to European music and even to Latin Indian. And they are very good examples from early music to music of computers also give a very good possibility to add statistics, new mathematics, fractal linguistics, theory group, etc. And also it's a very good help for the use of artificial intelligence. And you can use computers for neural nets, Markov chains, genetic algorithms, machine learning, etc., etc. Also, the mathematics very good possibility to use generation of formal structure with macro and microstructure. The computer-aided composition can be called CAO in French, computer aided by ordinateur, or in English CAC, computer-aided composition. And I like to give some examples of some software that is used in the composition for computer. The most famous is Open Music from the IRCAN in Paris, and a very good program that is very little known is Compose, written for Barry James, that was a student of Alejandro Casales. Alejandro, as the people know, was the first composer to use computers in the process of composition, the Iliad suite, in his university. And this person, Charles James, is a student by Alejandro, a program called Compose with the help of the Cursey Foundation. As I said earlier, computer-aided composition can be used also in tasking processing, but can be anyone. I like very much C-Sound, but Polyder, Mass, Pure Data, Chat, etc. My piece was take also into consideration the space and the best program that has to do with spatialization of music is the part from the IRCAN. Also Reaper is his software for tools, it's very expensive. And as I say also, use artificial intelligence, and the best program maybe is Wikinator and UP, made by Snackies in Paris, and use it early made for children, but now it's used in composer. Also, the general purpose can be used to compose, to digital processing, or by any generation or random process. A very good idea is the possibility to have real-time processing and light coding. Maybe the best of the use C-Sound. Finally, programming code can be C, C++, Java, Python, etc. Now I like to go into my piece. The title is Broken Cane. It's a piece for live percussion, marimba, vibraphone with digital signal processing. Let's explain a little about how I compose the piece. Broken Cane is composed with the help of revision C, and this revision C generates note, pitch, beat, structure, process of the entire composition. I used a lot of the diatonic theory. The diatonic theory was a theory generated by John Craig postgrad in the United States, in the University of Buffalo. Buffalo is an important university where teach Alejandro, as I said before, John Cloud, and they have two important festivals and one very important festival of music. I use also stochastic process and cell similarity, use it with the concepts derived new mathematical ideas. They are, as I said earlier, deterministic element and random element. The element that came from statistical procedure came from a distribution by Gauss, Pascal, Norman, etc. And I use also grammars. Isabel Lukaszuk by Curtis Road can use grammars in music and by top-down representation. In the stochastic process, I use random distribution, I use Gauss and Norman. Also, as I say, in the three important theories behind my piece are set theory, contour theory, ideas derived from the Gestalt psychology of perception. The set theory is an analytical technique used to analyze music basically from the 20th century and with special interest in atonal music. It was introduced by George Cantor in the 19th century, and I use binary relation that include operational interference, symmetry difference, multiplication, overset, etc. In music, Alan Fortin, Howard Hanson produced some combinatory operation, decisions, transposition, inversion, and I like to say that rotation can be equivalent to cyclic permutation. We can use sequences operation, transposition, inversion, retrograde rotation. The contour is an idea written by some psychologists in the United States. Is a curve that drives the served beat of the sound. Over time in music, the beat contours and the relative change in beat over time. And we can see that if we use the atomic scale, we go to C to D and D to F. The contour can be 1, 0, 1, 3, etc. This is that actually you see is also another theory, and the musical gestures can be used not only to content. There are three basic concepts: is special gesture, contour, segment. Gesture is the side of contour, like 0, 1, 3, 2. I can translate into 2, 0, 3, 3, 3, 2, 1, 3, 2, 0, 1, etc. Poesy is in the same special gesture, 0, 2, 1, 3, 2. We have 4 points: 0, 2, 2, 1, 1, 3, 3, 2, 4. We can ask why use this. This is an example in the center, in the special gesture, and we can translate into different places of the score and the space. As I say earlier, the three basic ideas from the composition and the diatonic theory, the group set, and the self-similarity process. In the diatonic theory, we see in this sampler, we can use C, F, A. We use cell similarity with this figure. The other one, the elementary was C, F, but we can generate A, B, C, C, gives R, F, etc. In the structure of music, it's very important, the structure, because I use the cell for the macro and the micro structure. We can use it. We can divide the entire book and the entire piece into sections and follow top-down theory. And in site development, you see for authors and see Reynolds, etc. This is an example of mosaic distribution. You can see this white space times E. These are influenced by this microphone. So, like this. This is one example of the grammar. This is the entire free movement. Every of this section is divided in subsection and in disorder. This is movement, succession. Also, another important part of the piece is the digital scenario. I use basically PD and max. There's also CSAM and repair, the effect, including the piece and the microtonality effect, phaser, version, Lux velocity and speed, so tempo, space, filtering. This is one example of microtonality in my piece. Let's see E, D, E, double flat, D natural, E. This is produced with one program, free software also, called Pratt from Amsterdam University. This is the one, the sound. And this you can move by in S. You can produce microtone, quartertone, and whatever. This is one part from pure data for progression up to modulation frequency and the carrier frequency, modulation index, digital, and this is for write the sound file, listening. Simultaneous loop also can produce delay and phasing of waves, and this gives me the possibility to change them. You can see this is the basic motive, one is basic, speed equal to 1, and a case for like Carter modulation, this is by 2, this is by 3, etc. You can listen the same motive with different speeds. Something Elliot Carter made using Nicole modulation. This is an example by people that they wait to produce loops. It's an example of the mosaic you can set not with different possibilities of rest. This is motive with different speed. You can see it here, here, and here. And also the random use of the quarter. This filtered. In this case is filtered. This is the grid. And to use noise, sound. This is one effect to produce preset chords. This is the in of the chords, and it's interaction of filter with several poles. And this is the mathematical expression that the possibility to change. This is some examples I introduced into the filter effect. The software that you use composition use store to set free to produce the score. Si sound, para data, hace free to control some parameters to produce the space. I don't use this path. And even it's very good because it's very flexible. The sound file can be processed with cutting and distribution of firmware. I set the speaker. I use 8 speakers. And this is the setup. This is the light performer. This is the percussion. And we can list light, effect, the speed, and the mixing, and the 8 loudspeaker around the audience. This is an example from Purata. First, I read something with 8 track, and we can listen in stereo or in 8 track. This is the stereo version, 8 track version. For the same audio file inside the red sound file. Distribution can be distributed for the performer or by the sound engineer. And I used maybe Spanish, maybe early. This is random. I write 8 because I like to have a possibility to hear the signal in the middle of the each loudspeaker. This is our distribution. Both paths are from Pure. Is the example from the score. Romer can click with one pedal, some is the mixer, and they get the control of the pitch. Bass, guitar, filter. My piece is light percussion, marimba, microphone. Recorded and or light recorded sound. I say and or because some possibilities of the concept is finished. As subject to go into the concept with how is the that is working. Maybe I was going with one very recorded material to be sure that the concept is okay. In contrast, broken gate is a piece with theory to the system position. I tried and I like very much to say in several conferences, concerts that lately is maybe it's very important the process of artificial intelligence and the music itself. I say here, this is aid for composition, is computer aided, no composition. It is a very good discussion about is the composers, computers can write music, who is the author. I always try to say that music must be produced with the help of computer, numerical relation, anything, but still music. My light profile is this presentation with based on reference. This is our stage, the student thriller. This is one of the seminal book about music. He was a teacher. This is an article about the theory, the legacy of cloud. This is general about mathematical music, the Alan Faulkner seminal structures of music, generative theory by Alejandro, other both seminaries, more elements of the music, and Roger Reynolds, who composed that. Mathematics, etc. Called Minds. Now I am time. I'd like to say thank you for your attention. If somebody has any question, that's the right.
No question. Okay. That's it. Thank you very much.
Okay, thank you very much.
Great, thank you.
Thank you. What about the sound check? Is there any audio files that you're using?
No audio files because I decided not to put audio files in my article. There are the reference for compact disc and so on.
Okay, good.
So,
okay, so our final presenter of the day, we'll start a little bit early since we're running ahead of schedule, which is good. Our final presenter is Massimo Avantaggio. Do you use your middle name? Massimo Vito Avantaggio.
Hello?
Hello? Can you hear us? Hello?
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 So I will start with my presentation.
Right, so, we have video problem.
My presentation is titled Some Consideration Around Time in Electro-Acoustic Music. I have some important terms here: relationship amongst stamp and untamping compositional experience, relationship amongst Chronos and Kairos, and compositional experience, acoustic music and multidimensional rhetoric, and further development in the field of study of electroacoustic music. Future direction of electroacoustic music analysis, and then I will cite many composers which are part of my analysis and research. In this article, I've analyzed some time concepts, applying them to a selection of electroacoustic pieces of different aesthetics. I talk about Tortamp, Antamp, Chronos, and Kairos. And with reference to the musical repertoire, I've cited works by John Adams, Navarette, François Bell, Donatoni, Filippo Tondo, John Tierzo. The fact that acoustic music is characterized by a sufficient degree of abstraction with reference to the more traditional musical parameters does not lead us to the conclusion that the management of time cannot be also considered at an analytical level. I will cite an emblematic case, amongst the others, which is the cycle Crystal World by the German composer Michael Lobst. Time and its management is important on a multidimensional scale and leads us to make further consideration on analytical technique. My article is composed by the following paragraphs: Ortamp and Antamp in the management of time, Chronos and Kairos, paragraph time modulation through technique, acoustic music and its multidimensional rhetoric, audiovisual and multimedia works, different temporalities in electroacoustic music, and the multiplicity of forms. The main concept of Ortamp and Antamp, with the term Ortamp, we define a time that precedes and regulates the development of a musical piece influenced by composer vision. Opposed to this, we have the work Antamp, that is the sound incarnation, or rather its translation into performance or fixing on tape. While talking about Ortamp, we can distinguish dialectic universe, which is the material universe, and the universe of forms, which are the rules of composition, construction, musical architectures at top levels, starting from microstructure to macrostructures. So, some consideration about the repertoire. We have cited different works from Filippo Tondo, Night Studies, Climb by John Harrison, Crystal World by Michael Lobst. All these work have a similar materic universe because they use percussion, but different compositional technique and different aesthetic result. In this slide, you can see the material universe of Crystal World, which is a piece by Michael Lobst. Attention to attack and release of every instrument that he uses in the composition. Or that is to play during motion. He also paid attention to the colors that all these instruments have. So, paying attention to what release means that the composer has a spectrum of the instrument and on its time features. A second concept is Ortamp and Antamp, applied here in Crystal World. Here you can see that the composer at the mini-structures level use different frequencies that divide the octave in different intervals. The harmonic system on which Crystal World Uno is based demonstrates that some authors do not merely compose the sound, but also use temporal differences that separates them and act on them during the composition. With some ratio, the composer arrives to sounds which are close to noise. So the composer plans to not only set the frequency he's going to use, but also the path from noise to sound, or vice versa. Another example is Donatoni Quartetto 3. Donatoni uses a frequency scale, o scala delle frequenze, subdividing the octave in constant intervals of 14 frequencies. This is the initial scala delle frequenze in Italian, and this is the initial sound material which offers the composer other transformational possibilities, allowing the composer the leveling of the material substrate. Other concept, chronological and chirological time. In various ways, these distinctions have been endorsed by composer and professional electronic music because the correlation between the perspective of absolute time and psychological time, even if not always recognized, are crucial to their craft. Schaffer, for example, talks about duration as a psychological and perceptual experience of time. Similarly, Oliver Messiaen distinguishes between chronometric or measured time and duration or perceived time. Chirological time instead tells us about time as an opportune moment, an instant of occasions, the measured time to perform an action or to make something happen, the inspirational moment in which you can dare and grab the kairos by the tuft, which is in front of its forehead. Other author refers to kairos as a temporal dimension of meaning which informs about the correct understanding and interpretation of events, perception, actions, and conditions. So it's important, what's important for the composer is the modulation of time through technique. How can the composer modulate the perception of audience, the sense of time that passes, and the overall quality of listener experience? Even if not exhaustively, we can point out some time modulation strategies. The first strategy is this change of state. In my article, I cite the works by John Thierryson and the work Klang, and the work by Michael Hobbs, Crystal Ball. These two works are very similar because they have a common strategy, which is adopted by both the composers, to introduce the original material substrate at the beginning of the piece. Okay, in this journey, a time scale can dominate or prevail in other by focusing on some features of material substrate or outlining the attractive sonic material information accordingly to certain dramaturgical choices. The same for the piece Crystal Liquid created by Canadian composer Mario Rodrigo. Mario Rodrigo here describes a sonic continuum inspired by two different physical states of water, the solid one and the liquid states. This is, in this slide, you can see the structures of the introduction of the first episode of Crystal World. There are 5 different subsections, and on the right you can see all the instruments which are used in the composer in the different subsections. And the composer creates different gestures in each subsection. Please pay attention also to the reverbs, because the reverbs allow the composer to simulate different amplitudes in machines that give an idea of a contrasting temporal phase signation. Other strategies regard the rhythm. I cite here the alienation of chronological music structures. In acoustic music, there is a tendency to alienate the chronological time structures because the object of the composer is to record traditional popular music, for example. And the composer wants to avoid the stripes pulsation, which is typical of popular music. I cite here Mambo La Braque by Alvarez and Penary Dracula. Another example regards the process of dephasing, which is generally exploited in a more organic way inside the minimalist boundaries. This technique, this strategies is also used by John Abbott in the Recital Zephyr and in some episode of his Invisible Seas. Also, it is used by Michel Chon in this piece, The Entrée of the Messe de Terre. Other strategies regard the overall shape of the piece. There are different strategies regarding the form. For example, sectioning the lengthy piece. For example, the message amongst panels, as a tool to determine a formal development of a piece. Studio 2 by Stockhausen, Fabrica by Michael Hobbs, Mambo Laverdac by Alvarez. Sculpting sonic materials into gesture or phrases, which are the middle layers of musical structures. And then you can use the pause in silence as a formal signal. For example, in the center of the piece to divide a work into equal halves. I cite here Fabrica by Michael Hobbs, the Quartetto 3 by Franco Donatoni. Other strategies regards movement in parameters such as timbre, pitch, duration, amplitude, space. These movement function as articulators of rhythm and perceived times. I make some examples citing David Hirst and Christensen. Other strategies regard the change of density over frequencies of sound elements over time, increasing the complexity of structures, the use of different psychoacoustic effects such as reverb, delay, and filter, which I recall that they give an idea of contrasting temporal and spatial coordination, and the generation of time, such as in Tilt by composer Mario Rodrigue. And then I continue with my list also with strategies that influence the qualitative perceptions, responses of a listener. For example, through the emergence of a symbolic and rhetoric language, activating synesthetic relationship, working on predictability of events. Neuron demonstrates through experimental method that events occurring at predictable points in times are more quickly and easily processed by the listener. So I talk about the multidimensional rhetoric in acousmatic music. This is the main theme of the fourth paragraph. We don't speak so much about rhetorical perspective because the question of the presence of a precise musical rhetoric within the acousmatic genre, stricto sensu, is aside or even avoid, even for the complexity that a discussion on this topic would entail. Particularly, this means diving into the ways that music is or is not like a language. By the way, we can check in this table that there are different levels of rhetoric and temporal association in acoustic music. They go also that regards also the spectromorphological characteristic, and temporal metaphoric relationship exists also between audio and other media such as video, poetry, text, and or more synthetically with multimedia or intermediate relationship. Then other temporal associations of sounds during space segmentation and during spatialization processes. So the treatment of space, the treatment of spatial movements, and so on. And then emotional responses of the listener to music stimuli. On the right, you can see all the people that study this aspect of rhetoric in a more, in a way, in different ways. Okay. Emotional responses. The listener emotional responses to music stimuli affect the feeling, induce states of mind, narrative, social, and meaning-related aspect. With regards to the last point, we should observe that music rhetoric embraces the confluence of emotion and meaning. Beyond being erotic and culturally rooted and situated, musical meaning is associative. The comprehension and enjoyment of a given audience has often much to do with audience members' familiarity with the genre. Every change in a sound will change the meaning perception of a sound, of a phrase, or of a sequence, and so on. And to a large extent, that meaning cannot be controlled regardless of the intention of a composer and how much the sound is different. So, this is an example by Raoul Ginsburg at Memoria. The first section of the piece, from start to 2 minutes and 22, is built around a system of rhetoric replies, appel, response. Okay? This is a simple example of how rhetoric works, considering the work by Ginsburg that you can find in the company's Metamorphose 2004. Rhetoric is also in relation amongst audio and video. As you can see in my article, in the 5th paragraph, sounds can influence temporality in different ways. That is to say, through temporal animation, temporal linearization, and directional properties. I explained the difference amongst these three temporal situation. All these three functions play an important role in the building of the temporal shapes of an audiovisual. In considering all these three aspects, it is clear that chronological organization and time management of events are only two parts of the same profile. Then, one of the last problem is the multitemporalities in music. In my research, I have experienced a great variety of situations, ranging from works in which the measured pulse is sometimes slower just to put in evidence some features of the chosen sound material. I remember here the piece by John T. Harrison Klang or Ginsburg to Memoria, with their grid-like structures, two pieces in which the composer experienced rhythm and temporalities in multiple ways, from a pattern of pitch, amplitude, timbres, space, modulations, and also multi-temporalities regards different rhythmic aspects. In Michael Obst, which is a cycle that I consider particularly important under this profile, musical times moves at different rates. The succession of episodes show different profiles, accelerating stage. Each one open up to different abilities and therefore to different perceptual dimension. The special attention to time management at several levels create a kaleidoscopic or perceptual plans that become from point of the cycle Vista-Pop. For example, in all the movements, different temporalities seem to exist. From motivic movement to constant slowing down to constant speeding up, from placing fractional polyrhythm to regular or stochastic intermittent assessment, from simple to complicated path. Here you can see an example of polyrhythms in Crystal World 1 at 3 minutes and 40 seconds. We have a polyrhythm with a logarithmic distribution. Another example, always in Crystal World 1, is the climax of the piece, which is divided into two parts. In the first part, we have a fondue enchaîné with sounds deprived of attacks and constant slowing down. In the second part, from 9 minutes and 27 to 9 minutes and 54, we have an accumulation with sound with attacks and constant speeding up. This is an example that shows that there are different kind of rhythmical situation and a different use of temporality in the piece. That works also, as you can see, there are sounds deprived of attacks, and then in the second panel, sounds with attacks. Another example is the intermed, which is a kind of interlude in the cycle by Michael Obst. We can check the regular distribution in the form that are accompanied by accelerating and decelerating gestures in stage, the first and two panel, in the third and the fifth section of the piece. This is the enlargement of the sonogram. As you can see, there are 5 panels, 5 different panels, and behind you can see an enlargement of the sonogram of the central part and the initial part, the central part is. Other consideration, in this musical cycle, the composer work on different temporal dimensions. This demonstrates that the multitemporality allows to increase the sense of variation and musical interest for a long work. Analytical technique developed in the field of automatic music are not sufficient to accurately describe the complexity of pieces like a crystal wall. And we consider here rhythmic composition by Rhodes and Grisek continuum of rhythm as an important starting point for further analytical development. For example, in this slide, we can see an explanation of the continuum of rhythm by Grisek. As you can see, rhythmically we move from order to disorder, from periodic to the rhythmic sides. When the rhythmic is random, there is no predictability. So we have an unpredictable breakdown of durations and the maximum of discontinuity. All this kind of situation can be checked in the cycle by Michael Hobbs. So periodic, continuous, dynamic, discontinuous, so. In the last paragraph, I talk about the multiplicity of forms, and I make this talking about different aesthetics. Spectralism, for example, composer described the sound object as a complex formation that can be dilated to create a thought process. Spectralists often start from the natural space, a natural delimited microphone space, to come to an imaginary screen where the composition is artificially projected. In landscape music, the composer sticks to an immediate description of the surrounding world. The aesthetic shadow of the world seems to prevail over the composer's subjective interpretation. In the soundscape composition, case is also a particular genre in which the already cited experience of time of being becomes a central factor of time awareness. I cite here Christensen, his book. Other example, in Quartetto 3, for example, we have a structures which is similar to an hourglass, as you can see. Okay, a reversed hourglass. Then in Alvarez, I make another example. In the cycle of cactus geometries, natural perspective influences the shape of the piece. Composer chooses some of his favorite cacti as a musical metaphor for some possible usonic topologies. Here there are some figures and of cacti used by Alvarez as a starting point for shaping the form of the piece of this cycle, cactus geometry. Then I cite some mathematical models by René Thom, mathematical models that are influential on works by François Bale. Amongst the shapes described by Thom, we can on the fold, the frond, dovetail, and butterfly. So we have different approach to have different shape and different musical forms, from natural to artificial. So these are some representation and graphic example by René Thom, used by François Bale. Conclusion: in acoustic music, the composer makes the listener travel through time, and to do it, he has to master different domains, from frequential to spectral, dynamic, and spatial. Time affects all these domains with various degrees, and compositional strategies may help to modulate the perception of time. In paragraph 4, we have described that compositional activity is influenced by multidimensional rhetoric, metaphoric relationship performance event should be taken into consideration at different levels, from sound object to spatialization. And the influence of rhetoric becomes more complex in the wider context of multimedia. I talk of this in paragraph 5. In paragraph 6, entitled When Placed Different Temporalities, we have reported the case of Hildebrand, a cycle composed of 4 different movements, in which the persistence of different temporalities allows us to point out how temporal and rhythmic aspects are covered by consolidated analytical techniques in a quite incomplete way. I have cited the rhythmic composition by Rhodes and Rhie continuum rhythm as an important starting point for further analytical development. Different and personal conception of times also reflect on the form of a work. The several examples reported in this article show that authors should demonstrate to have an important ability to work with sound and time, that is to be present and to draw audience attention to the present. And here I stop my presentation, and I'm open to questions by the public. Thank you very much.
Thank you. Are there any questions? No questions. Okay.
Okay, if there are no questions, just wish to thank you, KEAMSAC, and all the of the efficient organization, and I just want to thank you, Korea, for this great opportunity. And this is a work, engaging work regarding time and electroacoustic composition. I thank you very much.
Thank you. So this ends the.
Bye-bye.
Bye-bye. Let's see you. There we go. So this ends this year's KEAMS conference. Thank you all for coming. And the presenters who if they're listening, thank you for presenting remotely, for those of you who are not here in person. And hope to see some of you, many of you, next year also, or in the future. Thanks.